All right, welcome to the Electrical Safety Workshop. I'm excited because we got a lot of people in the booth right now, and we are having a blast. Where they're talking about the. Let me just first say, welcome to the Electrical Safety Workshop here at the Eaton Booth. Come on over. There you go. So Eaton has been a very dedicated attendee here at the Electrical Safety Workshop for many years. It goes way back to the inception when they created the Electrical Safety Workshop. We've been involved both from presenting papers to standing in the booth talking about electrical safety with everybody that we can to spread the news of safe work practices and the technical solutions that we bring to the table, whether they be a product that we bring to the table, a concept, an idea, a proper application of an existing product. It's all being talked about right here at the Electrical Safety Workshop. I'm excited to be in the booth. So we have a whole group of individuals that are filing through the booth, and so you're going to have to bear with us today because it's going to be exciting. So you're going to have different people who are going to be able to be with us at the booth. We're going to have different Eaton employees talking about their specific stations. So the way we lay this out, we bring individuals from the product lines who are the experts on each of these individual products, and we want them to interact with our customers and others who maybe other vendors here who are looking for opportunities to integrate their solutions with our solutions. So we're open to all different types of discussions in the booth, and we bring the technical experts from across the country to this site, this event, and interact with all of our customers. So we're going to have each of our groups from the stations. We have an arc flash resistant piece of equipment to my left. We have a automatic transfer switch demonstration over here, and because we're mobile, we may be able to be mobile. Come on over, Nihad. I'm live right now. Come on in. Nihad El Sharif, you've probably seen him multiple times on the program. Nihad, welcome.
Hey, Tom, how are you doing?
Excellent, excellent. So I was just doing the introductions, telling everybody about the booth, and we have our paper tomorrow. So every morning, Nihad and I talk about the day. So and today it's about our booth, and I know you were in here a little bit ago, help walking through.
Yeah.
So
I just got here, so I'll just have to do my tour, but I'll be walking around.
Absolutely. So
unfortunately, we can't film everything, but this room is big.
Yeah.
And there's a lot of cool things happening around here.
A lot of great things happening, and each of the booths, they're talking about solutions. We're talking about ideas on electrical safety, right?
It's like advancing safety. This is the slogan for ESW.
Absolutely.
Advancing electric safety. Yeah.
Advancing electrical safety. So yeah, so I was just giving them a little overview. So we have the arc flash reduction maintenance switch on a shunt trip safety disconnect switch, and the one that's over here is 400 amps. I don't know if you saw that one.
You showed me this in the morning. It was pretty cool.
Yeah.
Oh, yeah, I saw that. You're probably gonna be filming this. It's like,
yeah, we're gonna film it. Yeah, we're gonna film it. So.
And this guy there, like the mannequin.
What?
The mannequin there with the IEEE.
Yeah, we have personal protective equipment, and that's a recent solution that we're providing.
You had a program on it the other day. I can't remember how long ago, but I watched it.
Yeah, we had a PP on our YouTube channel. Don't forget to subscribe, hit the like button, and hit the thumbs up. And remember,
if you don't like it,
twice. If you don't like it, you have to hit the thumbs down twice. Absolutely.
Hit it twice if you don't like it.
Absolutely. Yeah. So we have the safety disconnect switch over here, and that's a 400 amps, but 24067 in the National Electrical Code sets the requirements for arc reduction maintenance technology or any type of arc reduction technology 1200 amps and above. So that's a 400 amp switch with the technologies that would meet the National Electrical Code if it ever went down to 400 amps. So it's kind of cool.
Like being proactive, I guess.
You know what? Here it is. safety if we don't do the bare minimum. And who was it? Lanny Floyd? Lanny Floyd talked about the bare minimum requirements and about how we have to go above and beyond.
Yeah, standards are the minimum requirement. It's not what you have to meet. And Lanny, I think it was at PCIC, one of the presentations, you were there, he talked about changing North American safety culture from compliance culture to risk-based culture.
Right.
This is more like the European approach of risk-based versus just merely complying to a standard, which is, or the standard that are the minimum requirement.
Right.
To just get by.
Yeah.
So it's just a different mindset.
Absolutely. So that solution over there is going above and beyond when it comes to electrical safety. There's my buddy. Hey, there you are. We got a great group of people here, and you got to come to the Eaton booth. If you are watching this and you are in Reno, Nevada, or within at least an hour's driving distance, because you'd have to get here, park, and then get in here.
Right, so
We're done at 6. This is 3 to 6. So we have the safety disconnect switch, and then over here we have our receptacles and a lot of different solutions on receptacles. And you're going to hear from each of the individuals responsible for each of these stations live here at the Eaton booth at the Electrical Safety Workshop in Reno, Nevada.
If you watched our morning video, you would remember that Tom is just getting ready for serious reporting here. He has his logo and
Absolutely.
This is a new channel, cable channel called Eaton.
Yeah, it's called Eaton. That's right.
It's a new channel.
It's a new channel.
So Eaton probably getting into the media business.
We are. We're all over it. We're all over it. Everywhere. Excellent. Yes. So I'm just looking at our schedule that we have here. Oh, we got so Willie Snyder. Hey, good to see you, Willie. Thank you for joining in. You smashed the like button 3 times. Excellent, as usual. If you want to smash the like button, it has to be in odd numbers. The thumbs down has to be even numbers. So thanks, Willie.
Never tell you that, but this is like the inside trader information that Tom has.
That's exactly right. Absolutely right. And Mark Elliott is talking to customers over here on the safety disconnect switch. I mean, it was just like a swarm of individuals coming in here. We've got personal protective equipment, our PPE individuals over here. We're going to talk about a little bit more of the booth. We're going to talk about training, and that's going to be Mike King from our engineering services division. We're going to talk about 70B, low voltage assemblies. AJ is around here somewhere. AJ has been doing a lot of great work with regard to taking product lines and getting them together, talking about how are we handling maintenance on equipment. And there are a lot of new solutions. You're a part of an IEEE document that's being created for continuous thermal monitoring, right?
Yeah, I guess both of us are.
I know, yeah.
P2629 or 2026?
Something like that, yeah.
Yeah. It's just it's something that started under a year ago, maybe under PCIC.
Right.
But we meet here as well. So PCIC and Easton.
And that's Peter Bain.
Peter Bain
is the chair of that, and we talk about continuous thermal monitoring of electrical equipment and how does it impact the maintenance of that equipment. So that's a IEEE standard that's still under work. Now, here's the other thing I think it's important to note, that you can be a part of that. If you're an electrical engineer, if you're an engineer, if you are involved with maintenance and whatnot on electrical equipment, you can, if you come to these meetings, find the schedule online of when they meet. If you attend 3 of those meetings, you're a part of the working group that's developing that standard.
And the best part is it's free membership. Everybody's welcome.
Well, that's right. You don't have to be an IEEE member.
No, you need to be a member of IEEE and SA for the ballot.
Or to
be able to vote. You have to sign up for it. But for the working group stage, all you need to just reach out to Peter Bain or the chair of whichever committee that you're interested in, like whatever standard working group you're interested in, and you're just more than welcome to.
I learned something already. Wow. So if you are, here's my message. If you're watching this and you want to get involved with one of these IEEE standards, if you reach out to me, if you're watching this, then you have my contact information because you're probably watching this on LinkedIn, Facebook, or YouTube, and I'll help you find the connections. Hey, you want to go live? We'll make you famous.
So Nelson is part of our organizing group. I'll let you introduce yourself.
Nelson, come on. Oh, no, you're on. You're on cue right here.
Hi, Nelson Amy, ISPI Consultants. We're here at the conference just learning what we can and helping other folks learn, just having a great time.
So
The registration guru.
Yes, I'm part of the registration committee to make sure people get in and get taken care of and that they get all the services they're expecting. And it's been a great conference so far. If you didn't come this year, try to make it next year. That's all I can say.
absolutely. How many of these events have you attended?
I have been coming to this event every year since 2008. I only came the first time to see what it was about, but I learned enough to realize I need to come every year, and you learn something every year.
And so you became addicted to it.
I did.
Aren't we all?
We are.
We share the same addiction.
It's a passion. It's a passion around safety.
What kind of addiction?
And everybody in this room, and everybody comes to this conference is passionate about safety.
That's true.
You know?
And had I known I was going to be on TV, I wouldn't have eaten everything that they serve us. They feed us really well.
They do.
I didn't know I was going to have this on TV.
I can't eat anymore. Otherwise, I won't be able to fit in my pants, and I need to wear it to go back home. Otherwise, I don't know how they're going to let me on the plane.
My wife told me I'm supposed to watch what I eat this week and lose weight, and it's not working.
You know, I watch everything I eat as it goes in my mouth, and there's just been so much of it lately.
Absolutely.
And they're walking around here with food, so I don't know what to tell you except.
So that's a good point, that you could pay for registration, come to the meeting, and probably never have to go to a restaurant because
correct.
you're fed.
I haven't been to a restaurant this week.
Yeah.
I know.
Yes.
Yeah. You got Keith Waters over here. Hey, there he is.
Come on over here.
We're going to get you online. Come on. Oh, man.
Guys, will be a celebrity here. Come on.
We'll make you famous.
I want that like this end of the.
Oh, come on, Wes.
Nika's at the conference, and that's why they should be here.
Absolutely. Come on over.
If you were wondering,
Well, if you have to put
should
it that
know.
way, you guys are better looking than me. So
The
you should come
association
on
we're
this
part of is participating. They should be here.
Absolutely right. All right. So we have a special guest. Special guest of the booth. Thanks for joining. And this is Wes Wheeler with Nika. Why don't you give us a little background? What do you do for Nika?
I'm the Executive Director of Safety for NECA, and some of the things that we do, as we just rolled out in our podcast, is we provide services to our members and our chapters around the country. We develop publications, we provide educational sessions for them as well, and so it's really an opportunity to come here. We have a Safety Professionals Conference coming up in Nashville at the end of May, so it's nice to see all the safety professionals, especially in the electrical industry, kind of get together at an event like this, and this is really outstanding to see this many people come together.
It's absolutely awesome. So tell me more about the podcast.
Well, one of the things that, NECA's been wanting to do some podcasts in various departments for a while, and we've expanded it with innovation. We have an Innovation Institute. We have a government affairs podcast that goes on that they actually have. So Mike Starner, the executive director of Outside Line Safety, and myself, we got together, we spelled out, some of the topics we wanted to cover, and so we decided we wanted to kind of institute that this year. So we've got a lot of things that are in the works. Some things I can't even talk about right now.
Right.
We've got some new offerings that are going to be announced
You know
at
what
the
I'll do?
NSPC.
I'll go like this.
Yeah, we'll go like that. We can't say that right now, but
Don't worry,
all I
no one is listening.
No one's listening. So no one's listening right now. But I will say that there's going to be some announcements at NSPC that I think will benefit our members and benefit our industry, especially when you look at safety and all the things that we need to do to really enhance safety in the industry. And I think we have some opportunities that are coming forth that are going to be great for everybody.
Yeah. Now, another thing I know NECA does well are your NEIS standards.
Well, most definitely. And one of the things that Mike Johnston and Kyle Krieger do, Mike is the executive director of Codes and Standards, NECA developed years ago the workmanship standards. When you look at the NEC, and what do you say is you had to be installed in a neat and workmanlike manner.
Yep.
But where did you go to find that information in? And so NECA took it upon themselves to start developing these standards. And we have a wide range from standards on installation of motor control centers. We've got standards on now energy storage systems. We've got standards now on microgrids. Electric vehicle service charging stations. So
Absolutely.
those are the things that when it looks to how are you supposed to do it, NECA's developed these standards, and the thing that I think we have the most success with is when we see these referenced in the contract documents and the specifications where engineers say, install it according to NECA, 2020 edition, 2020 edition. I think that those are some of the things that, really spells, the involvement we have with the whole electrical industry.
And it speaks to the fact that the engineer is looking for quality.
Exactly. Exactly.
Because it's about quality, and quality is very important when it comes to safety. The whole aspect of neat and workmanship-like manner is that you want to make sure that the solution that's being installed is done professionally and neatly, and so that you can maintain it throughout its life.
I can't remember how many times we talked about like presentations, talked about best practices and benchmarking, and just like doing the exact. I don't know, like pretty much every paper that was presented so far talks about the same concept.
Well, there are, and when you're looking at here, the thing that impressed me being here this year for my first time is, all the emphasis is being put on the safety professional involved with the electrical industry.
Right.
When you look at what we're doing, and just not only the electrical safety professionals, but how we interact with the safety professionals from EH&S and from IHs is that, are looking for how do they learn more about the electrical industry, and what are the safeguards, what are the best practices, what are the things they're supposed to be doing. And I think that that's really a consistent message here from everybody that's been speaking. And I think that, for me, that also, tells me this is something I need to go back and start looking at how we can actually share and get that message out as well. Because, in working with other associations like NFPA, I mean, we're involved in the Codes and Standards Committee, as far as, working on the technical committees, but we also have other involvement. We work with, the ASSP A10 Construction Demolition Operations Committee, to develop additional safety regulation standards that really help everyone in the construction industry. And I think that by having that voice, having that connection is really where, we have a voice at the table. We have a seat at the table. We're going to be, a part of it. So that way don't have somebody else just kind of dictating things. We have some input.
Don't be the last person finding out that something, And this is a good segue for a blog. So I know that Nika, I'm happy to hear that you're planning to get more involved. So let me tell you something. So IEEE, there are multiple societies. There's the society that I guess most of us belong to here is IS, Industry Application Society. And the Industry Application Society has 4 different departments. One of the departments is the PID, Process Industries Department. And I have the honor I'm on the board of IS, and I'm the chair of this Process Industry Department. And the department has 6 committees. Electric Safety Committee, which is running this show, ESW. PCIC, Petroleum and Chemical Industry Committee, which you're probably familiar of. Pulp and Paper, so Pulp and Paper Industry Committee. Metals Committee, Mining Committee, and Cement. So I would love to partner with Nika and do something, whether like it's educational, just like, cross-pollination, like there's different
lots of
groups
opportunities,
different knowledge, and there are gaps. We need to fill these gaps. So I would love to work with you.
Well, I look forward to contacting you, and you said something there also that in these other committees. I mean, you say you got a committee for mining. When you start looking at what the MSHA and the mining administration has done, where they're actually I remember when the NEC we used to exclude mining operations. Well, years ago when MSHA started adding NFPA 70E into some of their documents, some of their training programs, well, the NEC and NFPA said, hey, look, they're using it in mine, so we need to be referenced in mine. So that's a great segue to kind of look at how we cross-pollinate some of these industries, that we're providing the same safety services, but we're reaching a broader audience.
Reaching safety at large.
So Wes, I have to ask you, where do you get your passion for safety?
Where do I get my passion for safety?
Because you're passionate about it, and I love it.
Well,
where does it come from?
Well, it's one of the things that when I started teaching safety back in the early 1990s with the local apprenticeship program in Jacksonville, Florida, the Jacksonville Joint Electrical Apprenticeship Program, I think that having an impact, having influence, and helping people to go home safe at the end of the day, I've seen incidents, I've seen the results of incidents, I've seen fatalities that have occurred in our industry, and I don't want that to happen to anybody. And I think that, one of the things that when I went into business for myself to be a consultant and then had the opportunity to come to Nika, I'm like, this is a great opportunity for me to kind of, share my passion and do something good for the industry, and help others. And I think I've proven that in the last 10 years being in Nika, and I look forward to being here for many more years.
And I've known you for a long time, and I'll tell you, it rubs off. So I really appreciate everything you do for the electrical industry,
Thank
brother.
you, Tom, and I appreciate it. I look forward to speaking with you again.
Thank you.
Yeah,
thank you very much.
Collaborating with Nika on IEEE.
Excellent.
Thank you very much.
We'll be in
You do.
touch.
Awesome.
Thank you very much.
Thanks, Wes. Awesome. So, would you like to would you like to give us a little overview of the booth?
Yeah, are we able to walk around? Or
We can't. I can. So I have to unplug. And how about I give you the microphone, and then I'll follow you with the camera.
Okay.
Okay. There might be a little delay. Let me do this. You streaming?
Yes, we are.
Be careful what you say. All right. So we are.
Okay, Tom, I'll let you guys go on the booth, and I'll go around. I'll be back, and I will recruit more people for interviews. And you're looking for people. So
Well,
I'll do that.
only smart people like you, though.
Oh well, you set the bar
Which is
really,
why-
really low. Your bar is like way down there.
I'm not sure I qualified for that, but thank you. Appreciate it. We'll see you around. All right, Thomas, let's do it. So, yeah, we're here at IEEE Electrical Safety Workshop. Gosh, we've been here for probably like 40 years straight. How long has this thing been going, Thomas?
Gosh, long time.
Long time. So we really enjoy this show. It's fun to focus on just safety products versus, the typical approach is you look more at the kind of industry specs, and it takes a different angle on it when you're not necessarily talking about, how it functions as much as the safety aspects. So we'll take a quick spin through the booth and talk about, from a safety angle, why we got this stuff here. So in no particular order, where do you want to start? Let's go down this way. All right. All right, so the good news is there's plenty of people here. The bad news means I can't get very close. So let's go over this way. We'll meet our mannequin real quick. So we were going to do an interview with our mannequin, but she never seems to have much to say. But just by being here alone tells you what's important. So you see this is a 40 cal suit. This is one that we do offer through the Busman line, which is one of the Eaton brand names. What's cool about this is you can see it's the whole outfit. We got the leather gloves, you got the rubber gloves underneath, 40 cal suit, and if you could feel it, see, we actually call this, which is a little weird to call a 40 cal suit a comfort suit, because the fact is 40 cal is a pretty heavy duty suit, right? But 40 cal suit is pretty heavy duty, but this is a nice lightweight, because one of the hard parts we have from a safety standpoint, one time you put some stuff together, you start sweating, your hands get hot, you can't focus as well, you get dehydration, right? So it's a big deal to have a suit that's a little more comfort fitting, it breathes a little bit. So we got this puppy here, and I think whoever puts it on first and walks around, we pay for their admission to ESW next year. Is that what we're gonna do? That would be cool, wouldn't it? Let's see if we can work over here. All right, so what we're looking at here, you may have to just feel like the spot eye reporter of in the background here, what's going on, right? So we've got here is a 3-high structure that shows how we can do retrofits on insulated case breakers. So if we can get closer, you can kind of see we got 3 different kinds of breakers. See if you can reach in there, Thomas, and get a view. And why this is here from a safety perspective is that, especially in industrial settings, these breakers get a lot of wear and tear. They're designed, as we know, to be taken apart, to be conditioned, to be fixed and repaired, added to. But the fact is they do wear out, they do get old, and with that comes an awful lot of safety risks of how do you know that your breaker is properly functioning. And Thomas, how often do breakers actually really operate?
It's probably pretty rare, actually.
Pretty rare,
Yes.
right? I think, I don't know how it is for insulated case, but I think it's like 99% of breakers don't actually ever trip.
Yeah.
Which isn't because
They need to be tested.
Right, they do need to be tested, right? So chances are most of your breakers aren't tripped so knowing how well this stuff is operating is hard to do. So, but one of the things that happen is they sit there for forever, and what we can do is go in and modernize them, add communications to them, upgrade the trip units, all sorts of different flavors, and that turns into a safety play on the backside because now I've got more reliable modernized breakers versus some of those old dashpot dampers and whatever they might be. They just simply get old and wear out, right? So it's kind of we're highlighting here from that standpoint. And one of the things we were talking about too that we might be doing with these folks here is how you rack them in and out and kind of the safety aspects. And I think does it have arms on it?
Yeah, probably.
I think it does, right? So one of the things you could retrofit it with arc reduction maintenance switch, which allows somebody to drop the PPE level and don't have to wear that 40 cal suit. They wear something lighter weight.
Daily wear.
Right? They could go down to daily wear even, right? And so that's one of the things a lot of people are looking for is they're doing their arc flash analysis so they realize they got some hot spots. What can they do when they retrofill one of these breakers? Well, you put in a maintenance relay and now I can change the setting and it's safer to be in front of that breaker. So cool stuff over here. Let's take a walk. Let's do this. All right, so one of the, you guys can come over if you want. That's all right. So one of the things that's as important about a safety aspect is removing the person away from the hazard, right? So this is a remote monitoring station. So it's a Power Expert remote monitoring station that allows you to see inside the equipment that's on site. So you could put this kind of panel on the gear, but what this is designed to do is move just outside of the control room. So you're not necessarily off premise, but you're outside of that control room, outside of the arc flash boundary, and now I've got the access in my regular day wear, and I can watch what's going on inside all this equipment. So I can see what my PPE level is. If I need to go in there, I can see what breakers are operating. I can look at power quality metrics, all sorts of cool stuff. And I could do it here, as well as then now pull up data that says, here's what I should be wearing when I go inside. Or here's an instruction manual on how this stuff works. Really cool data. And I could take this data now, I can pump it up to the cloud into a bright layer, off-premise system and share that information as well. So kind of what's cool here, we don't have it connected today to the equipment, but we do in other shows and certainly in our experience centers and see how this stuff actually talks to the product. Yeah. ATS is, I don't know if I'm gonna go to ATS. Mr. Hume's got ATS. I don't know what he's showing about the ATS here, but bypass isolation switch. Hey, Charlie, give me 30 seconds on what you got here for the isolation switch. Just 30 seconds. This is around the room, super quick. We know we're going to hit you up later for a real interview.
This? Okay.
Yes, what we got here?
So this is a bypass isolation automatic transfer switch.
Talk to our friends over here.
I would think of it as, I tell people, think of it as two transfer switches in one. And what we're showcasing today is all the serviceability and safety aspect of this particular piece of equipment. It's compartmentalized, and it also has the ability to isolate electrically the control compartment for maintenance, easy maintenance, and safety.
There you go, right, yeah. Because as we talk about, maintenance issues is a very common time where electrical issues arise, right? I'm there because I'm fixing, repairing something, I may or may not turn it off properly. This is a big deal now to properly isolate loads, right?
And more importantly, because this is such a critical piece of equipment where you can't afford to take down your operations, you need continuous power. This allows you to work on the gear while it's energized, but being safe about it.
Cool. All right, we'll be back to talk to you in an hour or so, right? All right. All right, see if these gentlemen are going to talk about this product at all.
What's going on?
Justin, you want to see? I'm going to talk about this live. If you want to come over here with me, you can be on live camera.
I don't know if the labs would like that.
You don't have to. That's fine. So what we've got here, these are our safety switch offering. Am I on the screen there? Am I good? All right. Oh, I can see right there. So safety switch offering. So what we got focused on here is when we look at some new NEC codes, we'll look at 230.62. That's a service entrance requirement code. So service entrance is nothing new to have protection, but what's new is the requirements of what that looks like. So now there's more restrictions on just how you're allowed to access the live parts through a probe versus live fingers. And this little snap-on is a very inexpensive but effective way for us to do this. This is a affordable device. We want to make it too expensive to be able to add this feature to it. So it's a nice piece that is removable. It's got special clips on it. So we reformed this piece here, and now you got that protection built in. One of the reasons why we share this too is we do a lot of customization to safety switches. There's all sorts of things, if it's just as simple as color or some extra features inside. And what used to be a special, it would be an aux contact. Well, those are no longer specials. That's really popular. You can come in if you want. So this guy right here is a bigger version of that, but now we can see he's got a fuse switch, right? What this has built into it now is a couple things. One, if you can see behind here, that's where it's built in, where that aux switch is built in, right? So now I can now have this act as an e-stop downstream from motor loads, from other devices, which is what safety switches do, right? The point is you have to have a safety switch within a certain range of certain live devices. Well, now when I can put the aux switch built in as standard, now I can put that actual connection in and very easily control to turn that upstream, and not have to stand in front of this equipment. because it still carries the main power going through the system. So it's very likely that if you see an arc come through your network, through your on-premise infrastructure, it's going to come through the safety switch. So this guy right here is an arc energy relay that's built into this thing that now gives me ground fault protection as well as kind of an arc energy management system. There's lots of good information on this and why it's a nice little added guy to put in there. But cool feature to add to it to now again look at that safety aspects of the arc energy, being aware of what the power is here before I go disconnect it. Cool stuff, huh? Sorry. All right. And then back over here, say hi to our friends from the Cooper, Kraus, Heinz, Eaton side of the business. So we see a whole bunch of different, right there, whole bunch of different products here again, because this show is we cover the map here from heavy industry down to residential. So what we're looking at here are these wiring device options. This shows different ways of controlling the energy safely in a different surge protection in hospital grade, and then these special connectors that now are safer to remove and plug in. So this is insulated safe, right? Plugs back on top. And if anybody's seen it, when you start to plug things in and you want to put covers over it, one of the biggest issues, and one of the presentations earlier this week was just about that, of shock hazards, because when I want to plug things in and cover it safely, the industry just isn't there as a whole very well on making things safe to touch. And now I've got all sorts of features of different industrial kind of solutions to that exact problem. So come by and check this out too. It's pretty cool stuff. We make a lot of neat things like this. So Thomas, I think that's about everything we got in the booth. So cool to be here. It's a great audience, lots of great questions, and frankly, this is the audience that helps us, look at what the next safety features need to be on products. So it's a great time to be here, Thomas. I'm glad we could be part of it again and both share and learn from our friends coming through the booth. So come on, swing by, or at least virtually swing by.
Yes.
Can you need me for anything?
Hey, Jay Prick, look at this. Jay.
Oh, let me come down.
You're just in time.
Yeah, you're just in time. All right. Jay Prigmore. So the Jay Prigmore. What's so special about, why don't you introduce yourself? There's the camera up there.
I'm Jay Prigmore. I'm next year's 2024 ESW chair. So everyone come out to Tucson.
Tucson, Arizona.
Tucson, Arizona, yep.
Absolutely. So what's special about Tucson?
The weather. It's sunny over 300 days a year.
Absolutely.
And we got a golf course at the hotel. You're about 2 hours from Phoenix for MLB spring training. So lots of stuff to do.
Absolutely. So are you accepting papers, ideas for next year already?
Yes, we are. The paper deadline is May 19th. And we got a number of different topics like data centers. We could do mobile applications like, commercial residential vessels on marine applications.
Yeah.
We're looking at anything related to electrical safety and construction, the other, industries, and arc flash calculations, you name it.
So how many years have you been coming to the Electrical Safety Workshop?
This is my 7th year here. So my first year was in 2016 in Jacksonville.
Excellent.
And I was the first time attendee, didn't know anything. And somebody decided to ask me if I wanted to run a subcommittee. And I apparently said yes. And that's how I got sucked in.
That's awesome.
And then 3 years ago here at the Pepper Mill, I was talking to Scott Sieber and said that, I've had this committee for about 5 years now. I was looking to maybe step down and did my term and, do something else. And Scott came back a day later saying, Jay, I heard you were bored. How would you like to be the ESW chair? I was like, I can't say no to that.
Absolutely not. Absolutely. So what are the responsibilities of a chair?
I'll basically run everything.
Yeah. And you have a great team, right?
So yeah, there's a huge team that kind of runs itself.
Yeah.
But my main responsibility is to oversee that and make sure that all the cogs in the wheel are running smooth, right?
Absolutely.
And then I have access to the bank account.
Oh, hey, so I'm with you. I'm with you. So I produce the book. I work with Nihad to get things up on the website. So I will commit to you. I will help for next year as well.
Yeah, I already assumed you would.
I knew, but I just wanted to be on. I wanted to get it on tape.
Yeah, and you and I are on a couple of different committees together.
That's right. We're on NFPA 1078 and 78. And what does that cover?
That covers the guide to electrical inspectors and like how to perform them.
Yep.
And also qualifications for electrical inspectors.
And I have a very distinct feeling that next year you just might see a paper being delivered by these two cats on that topic.
Yeah.
Because it's very important. I mean, we heard it mentioned that there are a lot of people that come to this program. They're not just electrical engineers. So
No, not at all.
not at all.
I think most people that come here are not electrical engineers. Most of them are electricians, they're linemen, they're safety professionals. Maybe they're in charge of the EHS program at their company. That's our target audience.
That's the bread and butter, because those are the individuals that make the big difference for electrical safety in all of the organizations across the country.
Yeah, and I was just brought my mind, another topic we were talking about was forensic investigations. So those are very unique situations where you expect things to be dead or de-energized, right?
Right.
But you're an investigator coming in, say you had a short circuit and the fault, arc flash, somebody comes in there to investigate, what do you do?
Right.
And how do you know that it's safe to go into?
That's right.
And what do you need to look for? What if there's hazardous gases? Or a lot of times you come in, you have no idea what you're walking into.
Yeah.
So you have to analyze on the fly.
Yeah.
And, those types of investigations, we had some conversations earlier with the 2025 chair about writing a paper on that too. So
Awesome.
that might be coming up next year as well.
Excellent. So what do you do for Google?
So I work in the data center group. So I'm in Google data centers, and I'm in the quality team. So I manage certain vendors, mostly switchgear vendors.
Okay.
And basically I handle everything from the utility connection up to the input terminals and servers. So transformers, generators, you name it. And I am related to, or I get involved into everything quality. So anytime we have an issue with the manufacturer, we get involved, whether that's, post failure, whether that's, manufacturing issues like
Right.
recalls and stuff.
Right.
And then I also started our incident response team. So anytime there's a failure at data center, 15 or 20 of us engineers get pinged, and basically whoever's available helps support the site on getting back up and running faster and making sure they download the data and everything.
That's so you work as a team globally, right?
Yep.
That's awesome. Who implemented that? Whose idea was that?
Me and another guy implemented it. So
That's right. That's awesome. And you know what? That's what I love about. I get goosebumps just thinking about the people that are at this group are leaders in their companies. They're leaders in the electrical industry. And what I love about this event is we share our experiences. We just had Wes Wheeler here from NECA, and Wes said he's going to take all of the information back that he's learned here back to NECA and say, how do I implement some things? How do we contribute to this momentum that we've got? I mean, it's just awesome.
That's a great conference because, a lot of other conferences you go to may be very theoretical or equation-based, like I like to say it. This conference is very much hands-on, and it's a very good mix between a little bit of theory, a little bit of equations, not too much, but mostly lessons learned, best practices, and how can we help each other, be more safe.
Absolutely. I really appreciate what you do. So thank you very much.
Yeah, thanks.
You are the man. Jay Prigmore,
it.
thank you. Awesome. There's a sheet right there. I keep interviewing people. See that blue one over there?
Yeah.
There's a pen. Can you just make sure that we can use your video,
Oh, okay.
Yeah, sign your life away.
Yeah.
Awesome. Awesome. Yeah, that blue one right over there.
Okay.
Cool beans. Excellent. Thank you, Jay. Thank you. And hopefully we will see all of you in the at the Electrical Safety Workshop next year, and share what you know, share what your experiences are, and bring those experiences and that knowledge to these meetings, because everybody here learns something from each other. We all learn from each other. So that's the great thing about the Electrical Safety Workshop. So you want to talk? Come on over. So I mentioned 70B earlier, and we got Austin. So why don't you introduce yourself? Well, all right, you got the mic? I'm like a midget here. Yeah, here, take the mic. All right. I'm tired of holding it.
So I'm Austin Johnson, go by AJ. I'm the product manager for low voltage switchgear. So really here talking about the show, talking about how, late last year we started shipping out basically our new platform for low voltage switchgear. So everyone's familiar with Magnum DS. It's been out there for about 25 years. So now we've kind of got a revitalization out there with our Magnum PXR line. So one of the things we're trying to do with that is not just make that step into the digital age, but we also want to make things easier for folks. And that's where the NFPA 70B piece is coming into place. So with that, we realize looking at a lot of our documentation, it's not as clear as, say, some of the tables that you'll see in 70B. So one of the things we're doing right now is working with a couple of our field AEs to talk with customers, one, get an understanding of where their knowledge stands, and then showing them some things of what we're looking to do. So one of the things we want to do is go to more of a table format. Make it so you can find that information relatively easy.
Yeah.
We don't want to get rid of the details to make it so you can understand what you should be doing, but to get a better idea of what you should be doing and how often you should be doing it.
And do we implement things that modify that based upon condition monitoring?
Yep, and that's part of the whole what we want to accomplish by having a digital lineup. So the Magnum PXR switchgear line, it's basically giving us that platform to start building off of that. So some of the things we're doing are around environmental conditions, because those do have an effect on what your switchgear is going to see throughout its life. And so depending on what information you're getting back, you may need to make decisions on how often you do something. So, if you're seeing some fluctuations with heat, maybe that's a sign that, hey, maybe I've got a mechanical issue with some torquing out there, maybe there's something else going on. And I need to get someone to look at it, and maybe I don't need to do it as frequent now because you're going to get that information as soon as it happens.
Continuously. Absolutely.
Yeah, it's not, you're not going up and doing an IR scan once a month. You're going to have that information constantly fed in, and it's going to let you know, hey, something out of the ordinary is happening. You may want to take a look at it.
And you look at trends, like you say, you could compare data from a month ago, from a year ago, what your energy or what your thermal looked like on various terminals.
And it'll help you also address those intermittent issues. So you can't have someone standing in front of a gear with an IR gun 24/7.
That's right. That's right.
So now you'll be able to find out, like, okay, maybe you've been having some wiring wearing down because maybe something wasn't working well enough. Now you'll be able to understand why that's happening and when it's happening.
That is awesome.
So, that's just step one. That's where we're starting with, but we're going to be building off that. And that's part of what we want to do is ultimately find out the problems that customers are having, and we want to address them. So that's our whole mindset is how do we make things easier, and what information are we missing that they could possibly utilize within their setup.
Exactly. So I'll hold that. So 70B is very important for electrical safety. I look at 70B as like a part of the trilogy. I call it, you have 70B for maintenance, you have 70 for installation, and 70E for safe work practices. You need all three of those to work together to really provide a safe installation.
Yeah, because when you look at 70E, they have the expectation that the gear is going to function and maintained. So 70B is really helping to make sure that that is what's happening. So when someone's going up to operate on it, they don't have to have the concern like, oh, is my breaker not going to open? Is something else going to go wrong? And we want to approach that. And so there's the whole seminar that you're doing with Mr. Brady.
That's right. Next week, next Tuesday at I think 2 o'clock. Is it Eastern? I believe it is. I believe it is. Because
it's your presentation.
I know it's my presentation, but it's right there. It's on that sheet, isn't it? Hey, Jay, hand me that sheet. Right, the one that's upright. Yeah, there you go. All right, sir. We had it right. So it's the Understanding NFPA 70B, and it's going to be myself and Scott Brady. So Scott Brady and I both sit on 70B, and it's on March 21st. I did have that right, Tuesday at 2 o'clock p.m. Eastern. So we have a registration, and I believe that you can find that out on the website, or because you're watching this on my YouTube channel, LinkedIn channel, Facebook, if you're interested in that, shoot me a note, and I will send you the link so that you make sure you are involved with that. So That's awesome.
Definitely worthwhile. I know there's still more to learn because there's a lot that changed from the draft status to the release status. So
Yeah, and it's now standard. So now it has the you shalls instead of the you shoulda, you couldas.
yeah, and that's one thing, like even from our perspective, like we still as a company are learning. So we're doing a whole exercise to where we are sitting with our plants, doing an evaluation of everything we have in that year. And we're going to actually go through, walk through it, to get an understanding of where are those pain points. You know, what are people going to struggle to identify with? And one of the things we're going to do as a group is how much of a differing opinion do we have on what condition does this gear fall under? And getting an understanding so we can kind of provide some of that feedback to NFPA, like, hey, this is a real world, somebody utilizing this. Here's issues we had. Here's some things we can use clarification on, and hopefully to make the standard a little bit better.
Yeah, and I know we're a visual. I'm a visual person,
Yep.
and I know like that. I've seen people who collect like antiques or things of that nature, right? And they always have condition because you have to. The value of something is based on condition.
Yep.
So, and all of the books and references I've seen, just like baseball cards, whatever it is you collect, what's 80% versus 70%, and that could mean a difference between like 10 grand or something like that.
Yep.
So visuals and understanding what you're looking at and whether or not you're at the condition of that maintenance of that equipment, very important for the electrical worker when they're walking up trying to do maintenance.
Yeah, because ultimately the goal is, it's the reason we're here, it's safety.
Absolutely.
Prevent any issues before they happen. It's the best way.
Absolutely. You want to sign? You want something signed? Right there, that gentleman right there. So what they have here is what do they call that? A passport?
Yeah, it's a passport.
It's a passport.
15 signatures, I think, to be entered in the prize.
15 signatures, and they can be entered into a prize. Yeah, there it is. So so they have the list, and then on the back of that they have the layout of the what do you call it, trade show floor.
Yep.
And then they go through booth to booth to booth, ask questions, learn about the solutions. They sign off, and then they submit it. Hey, Kyle. There you go, brother. That's awesome.
Thank you for having me on.
Oh,
Is there
no,
anything else
thank you. No, I don't think so. Thank you. We're going to be maybe, I don't know.
Oscar's up next, right?
Oscar. Yeah, I think, yeah, you're right. Oscar's up next. All right. What's going on?
It's about the arc quenching devices.
You want to ask about arc quenching? Oh, here we go. You want to go? We're live.
On a webinar.
You're on the webinar. Absolutely. So say who you are.
Kyle Carb, Los Alamos National Laboratories.
Excellent. So why are you here?
Because I can come for a week, schmooze with a lot of folks, and my boss still pays me.
And we learned something, right?
Once in a blue moon, I get to do a paper.
And he has a special button on his shirt. It says, "Ask me about paper mentoring." So you're a mentor?
Yeah, so what it is if you're interested in publishing IEEE, but you're not quite sure how or whether it's even viable or how hard it is, then we try to walk people through the process.
Awesome. Well, that's awesome. So you help because it can be a process of developing the your basic, what do they call that? Not an outline. It's a
Abstract.
Abstract. I couldn't think of the word. So you develop your abstract, and it's submitted, and then it's reviewed by a group of individuals on the committee who determine which papers are going to actually be a part of the program.
Correct.
Excellent. And then if you're selected, you're on a timeline.
So it starts off not just as a paper, though they're starting to do that first. You have to present at a conference, one of the many conferences. Then of those papers or of those presentations, they can also have you publish a paper. So right now we're in the magic spot. We presented last year on arc sustainability at low voltage, and we still haven't done the paper yet.
Oh, okay.
Myself and two others. So there's a process before you actually publish completely.
That is awesome. That's awesome. So you said you had an arc quenching question?
I would like to know about your Eaton's arc quenching devices because I didn't know you had arc quenching devices.
Oh my goodness, yes we do. We have, in fact, we've got some patents around. So one of the key things with arc quenchers, remember there's sensors in the box, right? And the gentleman in the one presentation talked about it. There's light.
They're optical?
They're optical light sensors that they strategically place inside the enclosure. There's a relay that those sensors and CTs, the current transformers, monitor monitor the current that's coming into this equipment.
So you're also looking at the cleanliness of the current, looking for signs of arcs?
You're looking for that very high fault current that you're going to interpret as a fault. Now,
You can almost look at it as an industrial strength arc fault circuit interrupt.
oh boy, you gotta watch our paper. You gotta watch our paper tomorrow afternoon. So yeah, we're gonna have a paper on ASCIs. Yeah, tomorrow. So you're looking at the current coming into the equipment.
Did I
You're
walk into being a straight man for you here?
Yeah.
I didn't realize I was.
I love it. So you're looking at the current coming in. You're looking at the light, right? Now here's another thing that you've got to consider. Light inside of the equipment. If I have a fault downstream of this equipment,
Correct.
I could have high current passing through the equipment. I could have light because these power breakers, like you see over there, or your insulated case circuit breakers, when they open, they can generate light.
Sure, right through the contacts.
Exactly. So what we have done in our system is we can discriminate between what is in the box versus what is downstream of the box. So this system is looking at the current, it's looking at the lights, and when it sees the light and the current, it knows if there's any feeder breakers that are in the process of opening that's generating that light, and if they're seeing that same amount of current. And all of that happens in 0.004 seconds. It is absolutely phenomenal. I've got a few videos on that I can show you to show you the performance at 85,000 amps with and without that.
What we're generally looking for is we have a number of services that have abnormally high arc flash, and I believe that is a pretty universal problem.
Absolutely.
And nothing to trip on the primary side.
Yeah. So now what happens with the once we detect this, there's a tripping signal that goes to the upstream breaker, and then there's this blue box, which is the quenching device, and it creates a very low impedance fault almost inside that blue box, which basically pulls all the current into that box, taking it from the arc, and together with that and the fast clearing time of the overcurrent device, it reduces the incident energy, and that's how it all basically works. At a
Look at how it works through service transformers for an upstream fault.
you would have for an upstream fault.
No. So, for example, if I have a service panel with a main breaker, I hope, if I want to be code, that is, and I walk into a lot of these, many of these have a low downstream of the main breaker, but the upstream's pretty horrendous because the only thing I have is primary side fuses.
That's right.
Bayonets, basically.
Yeah. So here's a couple things. The National Electrical Code in 230, Article 230, put barrier requirements for the line side of the service overcurrent device. Now, what that does, it doesn't prevent the arc flash from going to the line side, but it reduces the likelihood that you can create an arc on the line side of the main breaker, right?
What about retrofits? Because that barrier requirement is fairly new. That's what I'm worried about is retrofits.
Yeah, so you can retrofit those types of barriers into that equipment now, but and some of that larger equipment, depending upon what it is already required based on 408, Article 408, to have a barrier like that.
Right.
Now, what an arc quencher, zone selective interlocking, or any of those technologies really don't do for you is that line side, right? So you can protect what's in the zone of protection. Now,
The question was, the arc quenching can reduce what's there,
Yeah.
but there's really no way to get credit for it, though they'll be safer while it's quenched until something like a fuse blows upstream.
Yeah. Now, and that'll quench what's inside. Now, if you have a fault on the line side, which what we do for the line side is we reduce the likelihood, not the severity, but the likelihood that you can cause one while you're in the equipment. Now, the best way, in my opinion, is to take your service and make it its own device. Take a safety switch like that, and then go to your lineup. Now you're not relying on the utility fuse, which is not designed to do anything.
Funny you should say that. We're doing that on one of our new buildings. We have an enclosure for the main the building and everything else downstream.
Absolutely. So and
it's a little late for my older buildings.
Yeah. So
which also don't have barriers.
Yeah. So the risk goes up, and you have to either address it in your procedures to say, look, this is how we're going to approach this installation, because we know the risk is higher, and because you know that, you know in the future installations on how you want to design for safety, which goes above and beyond minimum code requirements, right? So all of these safety features go above and beyond. Retrofitting into that equipment, in my opinion, if you're going to take that service equipment down and retrofit something in there to do something like arc quenching or whatnot, you're going to take it down anyway. Put a disconnect in, leave that equipment alone, put your arc reduction maintenance switch technology.
But done when you have a transformer, a hard
Space.
and a service switchgear.
Yeah.
Not something you can fit a disconnect in.
Yeah, that's the challenge, is the space. I agree.
So it's like retrofitting seems to be an interesting problem.
It absolutely is. And that's when you really need a good partner to work with you.
Sure.
And I know it's going to be Eaton.
I heard that there was good issues with bayonet devices on a primary side.
Oh, really?
Can you feed into those things?
I don't know. That's you're
If you
outside.
have an optical on one side and measurement, and you can trip the service, but can you also activate other equipment upstream, such as a bayonet shorting bar?
If you have a technology upstream that you can activate to say open, you can take
cases be closed.
Yeah. Oh yeah. Yeah.
You're grounding the medium voltage.
Yeah.
So
No.
the fuses go fast.
Yeah, you know what? And there's that concept, just what you said. And I know I've said this on my YouTube channel, and I tell people, more current is better, right? Because
trips.
It'll cause that device, that overcurrent device, to trip faster, which will reduce the incident energy. There is a misconception in my mind that a lot of engineers and others have, that they need to lower the fault current to reduce incident energy, and that could just be counterproductive.
Until it doesn't.
Exactly.
That's great until it doesn't. And the idea is there is a critical value for the types of breakers and protective devices you have, where all of a sudden it's off the table. You start going from instantaneous trip, short-term trip, to those long-term where you got nothing but self-rescue time, 2 seconds.
That's right.
That's what you're got to be conscious of when you make these decisions to lower the shorting.
Absolutely, absolutely. So I have seen relays that can tell an upstream device to open and trip, right? So you could trip something, but you're in the utility world, and the utility's only going to let you do so much.
We actually have an example that's interesting. Our utility provider has upgraded a lot of their transformers, made them much larger, gave us the new shorting circuits. All of a sudden, we've got lower incident energy on several of our services.
That is beautiful.
Good example, because things trip fast. Those primary side fuses only go, say, half a second instead of over 2 seconds.
Yes,
Things like that.
And you know, those things really, in my opinion, because it's utility follows the NESC. Those are requirements. I think utilities, I know in some cases they do it electively because they're providing that to their customers, but in many
cases they're just providing us more power, but it was a nice side effect.
Nice side effect. I love it. Well, there's always opportunity to make things like that a requirement in the NESC for the utilities.
Good talking to you,
Kyle, thank you. Thanks, everybody. All right. Excellent. Eric, you want to come online? Awesome. All right. This is another very good friend of mine, Mr. Stromberg.
Tom.
Welcome to what we call this Eaton Live, Eaton Tech Talk.
Tom Unleashed.
TD Unleashed. Yep.
TD Unleashed. Unplugged.
Unplugged. Oh my goodness. I almost went with Unleashed, but you know what? Maybe I'll make a URL for that too.
I think so.
Excellent. So, introduce yourself to the audience.
Eric Stromberg. I work for.
At least you didn't use that for your name.
Right. Los Alamos National Laboratory. So I work for the government. I'm here to help.
Excellent. That's awesome. So what do you do for Los Alamos? And I know sometimes if your boss is watching, right, and they go, oh my gosh, is that what he does? Right? So I know it's not, is it top secret? It must be top secret what he does.
I know. So Los Alamos is about 40 square miles.
That's a big facility.
It's pretty much like the size of Washington, D.C.
Wow.
And we've got about 1,500 buildings. And 50s, 60s, 70s, 80s on up.
Yeah.
It is an electrical museum.
Yes.
You walk in there and you say, wow, look at that. That looks like that switch here came off the battleship Texas after WW2.
But is it well maintained equipment?
Oh, yes, it is.
So there's, and I know you made a point on, we did an IEI News Live together, and you made a point which I thought was very interesting. Your comment was something like, correct me if I'm wrong, it may be old, it was installed to the standards and codes at that time,
right?
It's not necessarily unsafe.
Oh no, it's fine. But you gotta understand, you have to realize, you have to look at the effective ground fault current path. You have to make sure that all the I's are dotted, all the T's are crossed. It may not be the way we did it today.
Right.
2008 was a big year in the code for grounding and bonding and buildings and stuff like that. But so we have a lot of buildings from prior to 2008 that are built according to that philosophy.
A different philosophy, right?
Right, because what they did was they allowed a service to be at a structure and they allowed it to feed another structure, not run an equipment grounding conductor, rebond the neutral at that secondary structure. We have a lot of that.
Have you ever had any issues? I know we had a facility that had that situation, and we had some technical issues that we had to address because of that installation that way. Have you ever experienced anything at the facility that you had to address because of the grounding and bonding?
Absolutely.
Yeah.
Okay, here's the deal. Service point definition didn't come into the code till 1993. Okay.
I didn't know that.
And the code panel didn't really start cleaning up Article 250 till 1999.
Okay.
Anything before 1999, you really don't know what a service, separately drive system, not real well defined. So all the buildings that are built before 1999, a lot of them, people said, oh, well, that's a service. So they rebonded it.
Yeah.
And so now you have objectionable current. Now, okay, so this is what happened, and we're a laboratory.
Right.
So we have objectionable current flowing in all these metal columns and beams and structures.
So objectionable current is current over the equipment grounding of the system.
Neutral current over the equipment grounding. Well, when you have a transformer and a panel on the same, two different columns of the same structure, now you have a path in that metallic, in the columns and beams. Right. And then what happens is people bring in sensitive electronic equipment. The equipment doesn't like the magnetic fields.
Right.
And then they think, oh, I need an isolated ground. No, they don't need an isolated ground. We need to take the panels off the equipment and fix the bonding.
Wow. And you're right. I mean, I know there was a philosophy difference between bonding, and they called everything grounded, and then they called everything, you have to just bond and only ground at one point.
Right.
Yeah, so it makes a big difference.
And that's actually really, really new.
You know what? And here's my thing is I don't look at it new because I'm just a young pup, I guess. I don't know.
I think that the grounding and bonding, they added bonding to the title of Article 250. I think that was in 2002.
Okay.
So before 2002, it was just grounding.
Yeah. And then there's a big difference in how you treat that. So you have this huge, how many square miles?
40
square miles of facility you have to maintain. You probably have, you are a impedance grounded system, or?
No, we don't have impedance grounded systems at the lab.
Okay.
I worked for Dow Chemical for 24 years, and pretty much all our 480 volt systems were impedance grounded.
Yeah, it's a reliability thing.
Okay, you don't want to shut down a process.
Right.
Because some of these processes, it could be bad if you shut them down.
It would be ungood. That's a technical term.
Yes. It'd be ungood. So if there's a ground fault in the motor,
yeah,
we get an alarm.
Right.
The motor still turns.
Yeah.
Okay, we find the ground fault while everything's running.
Right.
Well, let's say it's an A motor of an AB pair.
An A motor of an AB pair. Okay.
So what we do is we say, call control and say, hey, MP111A, I need you to change the process to MP111B. And so the control room changes the process.
Yeah.
And then and the process is still running.
Yep.
Now, once 111A is shut down, we can lock it out, tag it out, pull the motor, replace it.
Excellent. I'm glad you didn't say turn it off, because it's an electric. You establish an electrically safe work.
You don't even know.
I love it. I love it. I love it.
Yeah.
Excellent. Excellent. So I know you. So how long have you been with Los Alamos?
2013.
2013 years?
Yeah. So I guess, yeah.
Excellent.
So that's what, 10 years now.
Wow. That's awesome. That's awesome. Excellent. Well, you do a lot of teaching as well.
I do.
And how long have you been coming to the Electrical Safety Workshop?
I think since 2015, I think was my first one.
Is that right? You know what? I cannot recall my first year. I've talked to multiple people, and they get to the ballpark, but I can honestly say I'm not sure. I know it's been so long.
Yeah, 2013 was in San Diego, and 2014 was in Dallas.
He even knows the locations.
It's the ESW.
It's the ESW.
ESW.
Absolutely. So where do you get your passion for safety? I know you do a lot of educating around safety. I know you talk to a lot of people about doing things the right way, interpreting the code. Where's it come from? Is it born in you? Was it created?
What a great question. I've seen some bad things.
Is that right? Yeah. A lot of people have, and that's what brings them here.
Yeah.
Yep. That's in something else. And now you're here, and you share your knowledge, and you make a better electrical industry with all of us.
You know, and when I'm teaching,
Yeah.
and I'm watching the students, or one-on-one,
Yeah.
you can see when the light comes on in the eyes.
Yes.
There's
Great.
That's it.
It's there.
That's
Absolutely right. And that's a great moment.
Yeah.
It is a great moment. Absolutely right.
Because you're changing lives.
You are. Absolutely. You are.
Yeah.
You're changing lives, and you want to get them young, and you want to get them at any age, right?
It takes longer to unlearn something than it does to learn something.
That's true. That is true. Yeah, that's a very good way to put it.
Yeah.
It's old habits, right? You have a habit, and then it's just like you just can't break it. You know it's not what I shouldn't be doing.
And there's also trust. I mean, your mentor, you respect him. And this is what he said.
Yeah.
Why would you question it?
That's right.
And then you go down through life, and then you learn that, well, maybe what he said wasn't quite right.
Yeah.
And now there's a personal relationship going on. There's, well, what about this? Why did this happen? How could he,
And you give people the courage to say, I don't know, I agree with that.
Well, I had a teacher once tell me, Eric, I may not always be right, but I'm never wrong.
I love it. I love it. I may not always be right, but I'm never wrong.
Right.
I love it.
Well, my mom, I was talking to her, and she said, I said, I've never been comfortable with the concept of trial and error.
Yeah.
And she said, well, how about trial and discovery?
Oh, that's right.
Yeah.
That's right.
Because we go through life and we do things.
Yep.
I don't like to call them errors.
Yeah.
They're not errors.
Discovery.
It's discovery.
Yeah. You discovered that you never want to touch that pot. Yeah,
Exactly.
that's right. I love it. I love it. Well, I'm glad you are here at the Electrical Safety Workshop. You are a good friend and a mentor to me as well, so thank you.
All right. Thank you, Tom.
All right, Eric. Thank you. Cool beans. What a great workshop. A lot of good people, a lot of good friends, and just a great time to share technical knowledge, technical information, and hopefully we got Ryan Jackson. Hey, Ryan, you should be here, brother. Yep, you know Eric as well as I do. It's cool beans. So if you have any questions, please, you can submit your questions, chat it up, share the video, because we're going to be going live until 6 o'clock I'm not even sure what time it is right now. So we're going to be going live till 6 o'clock p.m. 6 o'clock p.m. Pacific, which will be 9 o'clock p.m. Eastern. And then you know how to calculate everywhere in between, because I'm not sure what part of the world you're in, Ryan, right now. I know you're doing a lot more traveling these days. You want to talk? David, do you want to talk? Oh my goodness! You have a mentor button, and you don't want to mentor the industry? Come on! This gentleman is the guy who I first met, who brought me into Eaton. Yes, you did. You found a gold mine.
I was just telling these guys about this story about how I'm responsible for you being part of Eaton.
You are. Yes, you are. That was Tampa.
A lot of people
Florida.
are angry about that.
I know. Yeah, that's why you had to leave Eaton. So you have a button, just like, or a pin?
Oh, you've already been talking about this?
Yeah, Eric Carr, or Mr. Carr was talking about it, but tell me a little bit more from your perspective.
Okay, well, I retired from Eaton Corp in 2019 and worked for the company for 41 years. And so right after that, I became the editor-in-chief of Industry Applications Magazine.
Absolutely.
So it's a pretty high-paying job. But at any rate, I've been involved in the society for many, many years, and so it's a great opportunity to keep going. I go to the workshop here every year. It's just one of my favorites. And one of the things the committee does is that they just started this initiative to try to get new authors to write and present papers. And there's 400 and something people here, and 200 and something of them first-time attendees. So they don't know anything about the conference or how do you write a paper. And really anybody can write a paper. And this workshop for the IS is unique in that it's really about practitioners talking about case studies and really, what's going on in the real world. And so a lot of these people that work in a lot of different industries come in, and we want them writing papers. So there's a mentor program in the Electrical Safety Committee, and so I'm a mentor. So if you're a mentor, you wear a white button.
A white button.
That says, if you're interested in writing a paper, go talk to a mentor, and they can help you.
Excellent. You guide them through the process.
Yeah.
Or the process.
In Canada.
In Canada. That's absolutely right. So you're the editor of the IAS magazine, Industry Applications Society magazine.
That's it. Yeah.
See, I said it right, didn't I?
No, you didn't. It's the IEEE Industry Applications Magazine.
Okay.
You'll get this, I think.
I'll get it right.
Years,
yes,
you'll have it down.
With my mentor. Absolutely. So what else? What do you want to tell the world? Is there anything you want to tell the world about safety? I mean, you've been coming here for how many years? Why do you keep coming back?
This is, I think one of the things in the IEEE, and I'm involved, there's a couple of committees in the IEEE. I'm continuing to be involved. There's a committee called the Industry Engagement Committee. So this committee is actually appointed by the board of directors of the IEEE, and the Industry Engagement Committee is really charged with how do we get industry practitioners more involved and keep them coming to conferences, keep them writing papers. And so we sit around and talk about stuff like this, and the Industry Application Society and the IEEE, which is one of 46 different societies, is really focused on industries. I was the Process Industries Department chair for a while, so this committee, the Electrical Safety Committee, is part of that department, as is the Mining, Metals, Petroleum and Chemical, Pulp and Paper, and what did I leave out? Oh, Cement.
And cement,
So all of those industries have their annual technical conference, and so I kind of spent my career as an industry practitioner, and this is probably one of the best practitioner conferences of all time.
I agree, absolutely. The presentations, this started with a focus on the presentation and not the paper, and then the paper came after.
True.
Yeah. So I love the videos, the demonstrations that we see in this, and we learn about electrical safety. So I'm glad you got me into all this stuff. I really appreciate it.
You're doing good. You're making me look good, so that's good. Make me proud, son.
Make me proud, son. As long as you keep paying me, Dad. Well, that's beautiful. Well, Thank you.
Right, take
care. David. Always good to see you. Awesome. All right, so we're going to have another individual And this is Oscar. So Oscar, why don't you hello and welcome to
Yes, welcome to Reno, Nevada, right in the IEEE Electrical Safety Workshop.
Excellent.
Yeah.
So tell us who you are and what you do.
All right, so I'm Oscar Moreno, Product Manager for Eaton, and I will tell you what I do, but before that, let's start with challenges in the industry, right?
Okay.
Because that's very interesting. And here we are in the Electrical Safety Workshop, so we're going to talk about safety, right?
Absolutely.
Well, yes or no?
Oh.
Because that's not the only challenge that our customers have, right? I have been talking to a few of them already, and everybody says like, yes, safety, but I keep being pushed by productivity metrics, right? What about efficiency metrics?
Right, and that's pressure.
Yeah, because they have to do it, right?
That's right.
And in certain industries, there is some misconception that if you pursue safety, you have to compromise quality, or you have to compromise efficiency, or you have to, right? It's like a cost, like give and take.
Yeah.
I don't think that's the case necessarily. I think I believe that you can still achieve your safety goals and continue pursuing your productivity goals, your efficiency, and your quality goals.
You don't have to sacrifice any of it, you're saying.
You shouldn't, right?
I would agree. You don't want to, you don't want to sacrifice anything.
So let's talk about it, right? Now, other challenges, as same thing, as talking to people here from different industries, different segments, you can see how there is also the labor challenge, the workforce challenge.
Right.
Right? Why? Because people is retiring. They are getting to that time in which they're retiring. And believe it or not, the economy is still growing. So we continue seeing the growth in different segments, right?
Right.
So I guess long story short, there's going to be new people, new workers joining the workforce. And how do we replace all the knowledge?
Yeah, that knowledge base. Absolutely.
How do you do that, right? And how do you integrate younger people safely?
Yeah.
How you make them productive right away?
Yes.
All that stuff. So that's another challenge. And then at the same time, there's also this trend, like young people, younger than me, of course.
Yeah.
Everything is here.
Oh, yeah,
right?
it's all on the phone.
I mean, the other day I left home, I forgot my phone, and I was feeling like, no, I need to go back. Right?
Absolutely.
Because I don't know what's going on with my bank account, what's going on with my alarm system, with my thermostat, whatever, you name it.
Yes.
Right? It's all about information. There's this Industry 4.0 and the digitalization area and all that stuff. So how do we integrate all that stuff? It's like different things, but how do we integrate it? Well, with Eaton, we have multiple solutions for safety, and you don't have to sacrifice your quality, your efficiency, etc.
Right.
For example, in the power distribution monitoring and control, which is one of the solutions that we have with Eaton, you can get, as a user, you can get alarms and notifications on your mobile device, for example,
right,
so that you know immediately what's going on with your electrical assets, what's happening at the facility.
Yep.
Now, you are also able to get access to real-time information so that you can anticipate downtime. Some industries, downtime is very expensive.
Right,
very
right.
expensive, right? In some industries, if you disrupt services, you will sacrifice quality. So you have to know what's going on. You have to be able to anticipate that. You have to be able to react.
Right.
And information is power at the end of the day.
Absolutely right.
So that's what we enable with power distribution monitoring and control. That solution provides you with easy access to the information, immediate access to the alarms and notifications, and everything is available with a friendly user interface.
Yeah.
You know, so there is no guesswork. You don't have to be an electrical engineer with 40 years of experience to be able to understand what's going on there, right?
Yeah.
You get somebody who's not familiar, not even with your facility, and they will know exactly what's happening where in your facility, because it's very, very clear.
Yep.
You have to do this, you have an alarm, you have to follow these steps to see what's going on, etc., etc.
So what you can do though, too, and I'm just like, what I'm perceiving out of this is I walk into a facility, I have all this information. Now I don't have to, I can manage my time to focus. If I need to learn about a process and become more familiar with it, to understand maybe some of the data, I don't have to worry about everything else because now I can focus on it. So I can manage my own time to bring myself up to speed wherever I need to be up to speed instead of playing the game of just trying to put out fires and being reactive all the time. I can be proactive.
Exactly, and then also at the same time, that's true, and also at the same time, you give, it's transparent for the whole organization, right?
Yeah,
so it doesn't rely on you.
Yes.
Because it's a teamwork at the end of the day, right?
Absolutely.
So all that stuff is what is enabled with these solutions. So
Wow.
that's what
So what's the solution?
power distribution monitoring and control, and then that is actually applicable or it's available across low voltage and medium voltage equipment, which is also pretty cool.
Wow.
Because in the past, you used to have solutions for low voltage and solutions for medium voltage. Again, as you gain experience, you get familiar with the solutions and you get to know all that stuff, all the tricks, right?
Right.
Tricks. Well, not anymore. This is available across medium voltage and low voltage.
So let me ask you, does this system only work with Eaton equipment?
Well, we support Eaton and third-party devices as well.
Excellent.
So we integrate a number of devices into our assemblies. Not only power distribution, also motor control centers. So that's the other thing.
Okay.
So we go beyond that. We can expand into that. We support, of course, our breakers, meters, relays, variable frequency drives, etc. And we can integrate also information from third-party devices, such as temperature controllers, monitors, sensors,
yes.
all that stuff.
Excellent.
Right?
Yeah, because that's the whole other aspect. It's not just about the electrical monitoring, it's temperature, humidity, all of that.
All these environmental conditions, right? And again, depending on the industry, it may or may be more important or not.
Okay.
All that stuff is
Okay,
there.
so 70B, we were just talking to Charlie a little bit earlier about 70B becoming a standard, right? So, and condition monitoring, understanding temperatures and humidities and how many operations can help me focus my efforts on maintenance where I need to focus on it and not. So do you help in that as well?
Exactly, absolutely, yes. Everything is incorporated there. And now that you mentioned standards, it's not only safety and maintenance standards that we support.
Right.
Because again, the real challenges for the industry is not necessarily safety. It's a top priority, yes, but those are not necessarily the challenges, right? So another challenge is energy monitoring energy.
Right.
So we have also local energy codes that some users are required to comply with, and we support that as well. Because at the end, it's all connected. Connected devices connected, right?
Absolutely.
So the information is there, and you use the information for anticipating downtime, etc. But you're also monitoring everything. Just record it, and you have all the data available there.
Oh, absolutely.
So everything into one single package. That's what we are offering here.
That is awesome. That's awesome. So we can do the whole kit and caboodle.
Absolutely.
You are the man, Oscar.
Good.
So where are you located out of?
So we are located in Pittsburgh, Tennessee. That's where in Pittsburgh, Pennsylvania. That's
Pittsburgh,
where
Pennsylvania,
we have,
okay.
that's where we have the team. I'm also supporting, working from my home office in Memphis, Tennessee.
Memphis, Tennessee.
Yeah, so we're able to cover actually more geography, and really, I'm anywhere, right?
Oh,
the other day I was here in the West Coast, I went to the East Coast, I'm in the South, so everywhere.
And you gather voice of the customer,
absolutely,
and bring that back and help influence and change. And that's why one of the things I love about the Electrical Safety Workshop. You have a lot of people in one room from all over the globe, basically, because there's international people here as well, and we can take that information and build that into our product.
Yep. Absolutely,
awesome.
absolutely. And I'm very happy because I get to work with all different divisions within the company.
Well, that's right, because you have to integrate with switchboard, switchgear, medium voltage equipment, motor control centers, everything.
Right. I'm not the smart person, but I know who is the smart person.
You know what I always?
Right?
That's exactly right. And you know what I used to
say?
I used to say I am as smart as the individuals in my Rolodex, but that shows my age. Now it's got to be my contact list.
Absolutely. Yeah,
that's awesome.
So and it's been great. It's been great. We have been able to talk to many people, different people from all the industries, very diverse audience that we're have you. So good, very good.
And you all should be here.
Yes.
Next year, when we had Jay Prigmore, who's going to be, he works for Google, who is going to be the chair for next year. We had him here talking about next year's event because we got to get more people here to talk to people like you, the experts.
And people who has not been able to make it here just can go to the website. We have eaton.com/PD monitoring control. PD monitoring control. PD for power distribution, monitoring control, and you will be able to have a peek of what we're offering here.
That is awesome.
All right.
Beautiful, Oscar.
Cool. Awesome.
Thank you, sir.
Thank you, and thank you.
Awesome.
All right.
Woo! Tell me that's not awesome. So maintenance is a critical part of the puzzle, and the solutions that we have take information, continuous information, across all of your different pieces of equipment and help you focus your energy to make sure you are performing maintenance on the right areas of your power distribution system and not basically wasting time in other areas. Oh man, some people. I love it. I love it. So I see Tim McClochie. Thank you, Tim. I wish you were here, brother. We miss you. We miss you. And we're going to be doing great things together. So stay tuned for some more presentation materials and education materials out of the IAEI, where Tim McClochie and I are going to be bringing to you more NEC 2023 code changes and anything else we can get our hands on to help educate as many people as we can in the electrical industry. That is what it's all about. Take what you learn and share it. You may think that it's something that's simple, that is that you just think is just common sense, but just to others it might make a lot of difference and provide a little bit more insight and more depth of knowledge to their everyday business. So thanks for chatting it up. And we got Ryan Jackson, Willie Snyder out there. And Willie, I think I'm almost in your time zone too. So we gotta look for some other victims. We gotta look for. Did we have you, or do you want to talk again? No, I didn't have you. Yeah.
I thought it was up 5 minutes.
You're up?
I'm up now.
All right. Do I come over there, or do you?
Whatever you want to do.
Yeah, come on over here. So this is Charlie Hume. Charlie.
Hi, Charlie Hume, product manager for our automatic transfer switch line located in or just outside of Asheville, North Carolina. So happy to be here today.
I'm glad to have you here. And I tell you what, he has a product, you have a product that I love that speaks to electrical safety. Transfer switches, very mechanical device, a bunch of moving parts.
That's right.
You know, and you got to do what on them? Maintenance.
You got to perform maintenance.
And what's your solution to that maintenance issue?
So at least for this show here, what we're showing today is our bypass isolation transfer switch. The easiest way I tell people to think of that is it's 2 transfer switches in one. You've got, and it's all compartmentalized. So we have, our lower compartment an ATS, and above that, we refer to that as the bypass switch. And so when you want to perform maintenance, which you should regularly, and when your system is critical and you need to maintain power to the load, and you want to perform that maintenance while the gear is energized, this design facilitates that. Number one, based on the compartmentalization, you don't have to expose yourself unnecessarily to energized components or devices.
Okay.
And so with the redundancy, I have the ability to rack out my lower power switch, my automatic transfer switch, and exercise that to make sure that it's functioning properly. But of course, when I'm doing that, I need to make sure I can still transfer the load in case I lose my primary source of power. And so the bypass switch, which is also automatic in the upper compartment, does that.
Excellent.
So this was the design that Eaton had for many years. We started producing these back in 2008, and based on customer feedback, specifically from a hospital, that design has evolved and we've enhanced it. And we've introduced a third compartment now for the control compartment. So all our microprocessor logic, all our relays, the terminal blocks, all the components are located in a separate compartment that is now easily accessible because you have the ability to draw it out. And so you've got access to it to perform maintenance or inspection on it. And before you ever open that compartment, we've introduced something called a maintenance isolation switch.
Wait, is this in addition to the bypass switch?
Exactly. So this is another safety feature. We're thinking about the workers here, and so the worker has the option of when they walk up to the gear to be able to turn this switch, and that electrically isolates that complete compartment. So no system voltage, no control voltage. With that, you pull that open and you've got access, and so you mitigate the shock hazard.
Right, and are you still supplying power to the loads through that piece of equipment, but you are insulated and isolated from anything that is carrying power?
Correct. So you don't have to take down whatever it is your critical system. If it's a processing plant, you've got a conveyor that's critical, and that translates every minute of downtime translates into so many dollars of lost time.
Right.
You still have the ability to maintain and
that is, and maintenance is really critical on transfer switches. Absolutely. So if I have so this is all one unit, right?
It is.
And you have one of those, I think you have a video of one of those over there. Is that accessible online, that demo?
It is. You can, this is an interactive demo. It's self-contained. It doesn't require a network connection, if you will. It's you download it onto your laptop.
Yeah.
You open it up and you can operate this, if you will, and click on the different features, and it'll run through a slow little animation. And there's some informational hover buttons that you can tap on, and it'll give you some more detailed instructions.
Eaton.com/ATS. ATS. That's even simpler than the other. So Eaton.com/ATS. Go check out the demo. So here's the other question I have. That's an assembly. What if I love what you're saying, and I have an existing hospital, I have an existing tall building in New York City, and I say I want that bypass, I want that isolation, but I have an existing transfer switch. Is there anything I can do to retrofit? Is there anything I can do? Do I have to replace my existing? Can I add a separate switch? What are the ideas on retrofits? Is there any smooth idea out there?
Yeah, so what we see a lot with retrofits, Tom, is it's usually a conventional transfer switch that's being replaced with specifically this type of transfer switch, right?
Gotcha.
So we see a lot of hospitals where that gear is still functioning, and it's been there for 10 or 15 years.
Yep.
But for the reasons we just sort of stepped through, right, and a lot of the code changes or standard changes we're seeing in the maintenance programs,
right,
they want to have the ability to maintain this and maintain a high degree of reliability. And so that really necessitates removing that transfer switch and then bringing in this bypass isolation transfer.
And you have to think about the job of that transfer switch in many of those applications is life safety related.
It is.
And you want to make sure that whatever steps you take are not to try to get by with something that is inferior to what the latest products are. And if you're going to have to take that switch down anyway for whatever purposes, it's just take that one out, put this new one in, and then possibly bring some updates to the installation. Per the NEC, there's another inlet that's required for when you do maintenance. Do you need that inlet if you're doing this? Or are there any exceptions in the code that recognizes that yet?
Not that I'm aware of.
Okay, so you would need, like, if I only have one generator, one transfer switch, the NEC tells us you need to have that separate inlet so that you can bring a temporary generator in just in case, because you're going to probably take your generator down.
Well, so there is in an emergency system, Article 700, and the exact section escapes me. I want to say 703.f. But there is a requirement, that if you're maintaining or performing maintenance on your permanent generator, that you still have the backup power readily available, which necessitates the need for some sort of inlet, whether it's a cam lock receptacle or what have you, to bring in that temporary backup supply. So that's the one instance.
And that's relatively new too. So if you had an older system, you don't have that input. And the reason I point up there is because I know Ryan Jackson is going to post, hopefully, the exact section that we're talking about.
Now, there is a change that you and I are familiar with, right?
Yes.
In the National Electrical Code 2023, that there's now a requirement for, in certain situations, either redundant transfer equipment or to have a bypass isolation transfer transfer switch. So that's new in the code.
Yeah. So when you're designing a new system for those applications, you're better off just going with something that helps you meet that code and gives you the maintenance capabilities for a transfer switch. Because, we made a change in selective coordination because there is a reality in the industry that the generator might not start and the transfer switch may not transfer because of various examples, probably related to maintenance, that the product like that could really help the reliability of the power distribution system and change that probably some would argue a misconception of the reliability of relying on that transfer and the generator to start, because we're supposed to be doing maintenance, we're supposed to be doing testing, and if you don't do that, then things aren't going to go
I like to draw the comparison to a car that you might have, and you tuck it away in the garage, and you don't use it for several months, maybe a year, and then you decide one day you want to take the car out and take it for a drive. Well, just expecting it for it to start and operate and perform regularly.
Yeah, you're going to have to do what I'm going to have to do soon, because I got to go and take my pickup truck to go get some gravel, because we're going to put a little patio in the back.
Right.
And my pickup truck's been sitting in the driveway for months now. And I know when I get in, the first thing that's going to be dead is the battery.
It's the battery, right.
Absolutely.
Right. So we recommend that people exercise their transfer switches regularly to make sure it's functioning properly. So when you do need it, it's going to be there and it's going to work the way it's.
Absolutely. And a lot of that's covered in NFPA 70B.
Correct.
And I think you pointed out 110 also includes some recommendations on maintenance as well.
It does. So Chapter 8 in the annex, there is a recommended, sort of best practices for transfer switches, and it talks about major maintenance on an annual basis, and then it talks about quarterly inspections, and it details some of the things that you may want to incorporate into a maintenance plan.
That's awesome. Yeah. Awesome. I'm loving it.
Yeah.
I've got a passion for transfer switches now. Everybody should at least have 2. Or 3? Yeah, act now. It's beautiful. Anything else you want to say to the group? How long have you been coming to the Electrical Safety Workshop?
This is my first time to this show.
Really?
I'm enjoying it. Yeah, this is great turnout. We've got great activity at the booth. I've had some great discussions. It's a different group of people that I've not spoken to directly before. So yeah, I'm enjoying it.
I know I see you at the ASHI conferences, and you go to a lot of conferences. I thought you were always around it, but this is great.
No, I'm a newbie.
You're a newbie, and a very smart newbie at that. And that's the value of being here. Talk to gurus like Charlie here. It's cool being.
Thank you, Tom.
Thank you, Charlie. Appreciate it.
Bye, everyone.
All right, check out the website. So Eaton.com/A, T as in Thomas, S as in save. So check that out. All right. We have a lot of individuals coming through the booth. We have a lot of people throughout the entire facility. I wish I could turn around and show all of the individuals who are all talking, and they're all talking probably about electrical safety. In each of the booths, they're probably learning about new solutions that they need to bring to the market, and opportunities to improve solutions, and opportunities to improve our, just how we do it. You may not need a new product. It just might be how you have it installed, how you maintain it, and how you operate and install it. So I've got to get our training person in here soon, and I've got to get our personal protective equipment person, Michael. Mr. King, when you want to talk, brother? You want? Yeah, we're live. Yeah. I love this. You got to smack him up the side of the head here sometimes. Oh, look at this. He's bringing a book. Whoa.
There we go.
Look at that. He's got is that my copy? Mine was
Yeah, I will keep it.
I got one. So tell us who you are.
So my name is Michael King. I'm with the services group within Eaton, and what that means is services has all the responsibilities for startup, commissioning, maintenance, troubleshooting of equipment once it's installed on sites. So we support our customers that way. Also, and my role is really tied to training around that. So if you look at us from a historical standpoint, we train our own employees on how to operate and maintain all that equipment, as well as all the theory behind behind how it works. Because how do you troubleshoot
Right.
if you don't know how it's supposed to work? In the past, I'm going to say about 5 years or so, we've transitioned to not just training our own employees, but let's share that knowledge with the world. How do we make the world a better place?
Absolutely.
And that also means a safer place, which is why we're here at the Electrical Safety Workshop.
You are the man. So how many years have you been coming to the Electrical Safety Workshop?
Me, myself, probably 8-10 years, probably. It's been a while. It's been a while.
Excellent.
Missed one or two in the middle, but
Yeah.
been here. And then, we tie 70B into this now, which I know you're involved in it somehow.
Yeah, I'm on the
Did
committee.
I read that? Did I
Yeah,
read that?
you could find me in there. I'm it's myself and Scott. So Scott Brady, who works also for the Engineering Services Division, and Scott brings a lot to the table. More so, I have over current protection knowledge. I have general system, but Scott is integrated with actually working on this equipment as you are as people in the Engineering Services Division, and not just Eaton equipment.
Right.
Right, because you get exposed to a lot more than just Eaton equipment.
Yeah, I mean, my conversations personally, talking about training, is all right. I maybe as a customer want to maintain my own equipment. You can do that, right? I mean,
Right.
that's permitted per all the codes and standards out there. Or maybe I hire a third party in. But either way, testing needs to be done. Lubrication needs to be done, right?
Right.
And if you don't understand what needs to be done, how do you follow this standard? How do you follow the other
Oh
standards?
yeah, or if or
70E?
worst case, if you have a little bit of information and then you use the wrong lubrication or the wrong cleaning agents, you could create more problems. And there was a presentation which I thought was really intriguing because he made the point that sometimes opening those doors and performing that maintenance when it's not necessarily needed, because maybe you have the condition monitoring and you have a better understanding of the equipment, that if you don't have to perform the maintenance, then don't, right? And focus your energy on the parts of the plants that need that focus.
So I have an example for you.
Oh, beautiful.
Yeah, you're gonna love this. So years ago, let's go back 20 years, 30 years.
Yeah.
Finger clusters on the back of breakers
Yeah.
were all greased. That was the standard. Every manufacturer did that. Okay, maybe we use different types of grease, but we greased them, right?
greased them.
And then we switched over, I'm gonna say around 2000-ish, we switched over to paraffin wax.
Paraffin wax.
Yes. And you've seen it on breakers, Tom, and you've never realized it.
Really?
Yeah, when you've been to the Experience Center in Pittsburgh, right?
Pennsylvania, yes.
Or now we have one in Houston too.
And in one in Houston.
Absolutely, where we do all the training out of. But if you look at our Magnum DS breakers, you look at our VCBW, which is current production, all the finger clusters are blue.
Oh yeah.
And that's not because we're Eaton. I mean, it sounds cool, but
Gotta be blue. Yeah.
Right?
I mean, that's my argument.
but it's paraffin wax. And the thing is, when you grease finger clusters,
Yeah.
it's there so we lubricate, we don't get corrosion on the finger clusters, but it dries out over time. It collects dust.
Yes.
The paraffin wax doesn't dry out, it doesn't collect as much dust. And now, if you read the instruction books, it'll tell you instead of grease every maintenance cycle, it says replace the paraffin wax as needed.
Ah.
And that could be 20 years. 30
Oh
years
my
now.
goodness! And I tell you, I've seen pictures of like medium voltage circuit breakers and whatnot where the grease was like dried, and that would be ungood for those clusters.
Right, absolutely. So now what's interesting is I talk to a lot of contractors, a lot of facility equipment
Yeah.
owners, right? They have somebody on their team that's been around for 30 years maybe, very
Yeah.
experienced. They grew up learning you grease finger clusters.
Yeah.
So now they take the paraffin wax, and I've even heard some customers will scrape it off the finger clusters to then grease them.
Oh my goodness.
Which is absolutely the wrong thing to do, right?
Right.
It's against the recommendations.
Right. Oh, that is real. So what is paraffin wax? I mean, is it? Do they like to grow it off of paraffin trees?
That's a great question.
We're gonna have to look that one up.
Where's my phone?
Yeah, no, you know what? Before 6 o'clock, we're gonna have to figure that out.
Yeah.
Yeah. So, but my story is they come from paraffin trees.
I'm going with it.
All right, we're gonna go with that.
Yeah. So it actually got to the point where if you walk into, well, my office is gone because we just added new training rooms in Oregon.
I saw that. I saw that on LinkedIn. You have to follow Michael King. Find him on LinkedIn because he posts all of these great little videos and pictures of all the training and education, all the resources we have as Eaton. So you lost your office?
I lost my office, but I still have it. It's just sitting on my table that I call home now. I have a actual container of the paraffin wax.
Oh, really?
Purchased from Eaton.
Think I could put it in my hair?
You could. I mean, maybe that's what I'm doing.
It could be blue. I could be like a Smurf hair. I like it. I like it.
So, I mean, it's so important to
And
understand.
that's a detail.
It is a finite detail, but it's so important.
Absolutely. Absolutely.
I was actually thinking about you in this conversation today, last week. I'm gonna be honest.
Really?
Yeah, I was. So I was teaching a class, and we got into control schematics for medium voltage.
Right.
And I love this conversation. You have the red light on a medium voltage breaker.
Right.
Which means the breaker is closed, right?
Yeah.
That's what it means, right?
Right, because it's red.
I'm going to argue that's not why it's there.
Okay. I'll tango.
Buy it, right?
I'll buy it. Okay, let's go.
So, if you look at a medium voltage breaker, you'll see the red light comes down. It's in parallel with the relay.
Right.
That trips the breaker.
Yep.
Goes through a contact, so an aux contact of the breaker that closes when the breaker closes.
I'm buying what you're selling.
To the trip coil.
Okay.
Through another A contact typically.
All right, it's a journey.
That's the whole circuit.
Okay.
So we have light bulb feeding two closed contacts. That's a trip coil that's always energized. Anytime you close the breaker, why doesn't the breaker trip? Anytime we close it.
It needs to be charged.
It is charged.
Oh, it is charged.
Yeah.
Oh, it's closed.
It's
Yeah.
closed.
Yeah.
So why do we put a red light in series that should trip the breaker every time?
I don't know.
Well, the light has a high enough resistance. There's never enough current flow through the light to actually pick up the coil. Right?
Wow.
All right, but it gets better.
Okay.
Because why would we do that? There's got to be a reason.
There's got to be a
Every
reason.
manufacturer does it.
Integrity of the circuit.
Absolutely.
Whoa, I figured that one out.
You got it, right?
Wow.
It's a monitoring circuit for the trip coil.
Oh my goodness. So that tells you that your trip coil and that circuitry is active. You're not drawing enough current to trip the breaker, but you are drawing enough current to light the LED.
Absolutely.
Bam.
Now think about that. How many times have you walked into a switchgear room, seen closed breakers,
Yes.
and the red lights are not all on?
And I never really thought about it.
Is it a bad light bulb?
Is
Or
it a bad trip?
trip?
Oh, so,
Right?
yeah.
So now let's tie 70B, right? 70B says you got to test that circuit, got to make sure it works, right?
Right.
Otherwise, the breaker won't trip. Your arc flash 70E just went through the roof.
Oh man. So is that standard on everybody's breaker? Or is that just ours?
Everybody's.
Everybody's breaker.
It's the unwritten industry standard.
It's an unwritten industry standard. Then why don't we write it in a standard?
We should.
Yes, I think
let's
we
get
got.
together on that.
We are going to get together on that.
Now, little new note to that.
Yeah.
Now we're installing microprocessor and solid state relays
Right.
that can have a monitoring circuit built into the relay now, which is in parallel with the light that was already there from before.
Oh.
Now, one question I have not figured out is how many relays and how many of those circuits can you have in parallel, before you get a trip? I don't know that answer yet. But we're gonna
I
figure it
know.
out.
I
We're gonna figure it
know.
out.
He will figure it out.
So I mean, those are all details, right? But
Yeah.
when we talk about 70E, we talk about the National Electric Code 70, we talk about 70B, and we say we want to make a safer world electrically. Both
Right.
equipment design, operation, it all becomes important. It ties together.
Absolutely right.
And nobody knows everything, right? I mean, every time I talk to you, I learn
I
something
know,
new.
and I do that. I just learned about this. I mean, this is the interesting thing that when someone says, I think I know everything or I know everything, you know they're blowing smoke because there's no way you can know everything. And these little details could mean a lot in the performance of the equipment.
Absolutely. Absolutely. So how do we get better? The only thing I know is we all take training classes from each other, right?
Right.
We all come to conferences like this.
That's right. We share experiences, share knowledge.
I don't know if we hit a record this year for attendance.
Oh, it's huge. I know.
I mean, over 200.
200 new first time. Oh, yes. I was going to say
amazing.
first time employees. First time. Jeez, oh man. First time
We're gonna hire them. Don't worry, we're
attendees.
gonna hire them.
Yeah. Yeah.
But I mean, honestly, like this is great to see how many attendees are here, how many
Absolutely.
first-time attendees, and the conversations. I mean, we're having these good conversations. Honestly, I've heard some other conversations blow this one out of the water.
Oh, I know. And as I look through everything, everybody's talking about it.
Yeah, absolutely. People are walking by. They're waving.
Absolutely. You want to come online? You want to talk to the? We're streaming right now. We're live streaming. Oh, look at that. Come on over, man.
We got the crew.
Okay.
Okay, they're coming.
Okay. All right. All right. Excellent. Excellent. So education and training. So you do training for just about anybody on anybody's equipment.
We do training from literally non-qualified electrical workers that maybe walk through those rooms, maybe are cleaning those rooms out, mopping the floor, right?
Yep.
Need to be aware of the hazard that gray box represents. The whole way up through the operators, the service providers, the design engineers.
Yeah.
I mean, it literally is everybody. I get financial people,
Oh yeah.
coordinators coming
Yeah.
in. Something.
Now, so I know medium voltage is important, low voltage is important, but what about control circuits and even that lower voltage control aspects? Do we teach on that? Do we have classes on that?
Yeah, I mean, so a lot of our control stuff is built into those higher voltage classes. So,
Okay.
I mean, when we talk about a 480 volt switchgear, low voltage,
Right.
but now they have PLCs in them.
Oh,
Right?
yeah.
They got all the control circuits, and
That's
if they don't work, the switchgear doesn't work. So
Okay.
we do cover those.
So say a customer, say somebody out there in YouTube land or LinkedIn land or Facebook land says, I have a situation, I need education on this application, whatever it would be. Could they call you and say, hey, can you tell me if you can offer training to customize it for me?
Yep. So our website's www.eaton.com
And
/ EWT electrical worker training. Either
Excellent.
one will actually work.
and if they purchase training and they put
Tech
Eaton
Talk.
Tech Talk,
Yep, Eaton
all
Tech Talk.
one word, you could get a,
What did we say? 10, 5?
I think it's 5 or
boy.
10%.
I think
We're going with 10% discount.
We're going with 10.
Yes.
Change it. We'll make it 10.
I love it.
Yeah, but the low voltage. Actually, last week I had a class,
Yeah.
and if I remember correctly, ZSI, zone selective interlocking.
Yes.
That's a 5-volt signal
Oh, absolutely.
between the breakers connected, right?
Absolutely.
So how do you test those breakers, and if they're not working right, how do you troubleshoot?
That's right.
Why it's not working? And
Yeah. And do you have to worry about interference?
they use twisted pair wire.
Exactly.
I mean,
And there's a reason.
right? And then if you're talking mains, high mains, we have diodes
Yes.
in the circuits to make sure voltage flows the right direction.
Absolutely.
So yeah, no, we get across the board, start to finish. How does the equipment work? How do you design good designs? Just that's the other thing I run into a lot is people say, "Well, I'm designing a system. Tell me what the NEC says I have to do to design this." And we know,
Oh,
you're
man.
involved, right?
Not a design guide.
Not a design guy.
Absolutely right.
Minimum
Absolutely. And
requirement.
there's statements in there that says that you can design it to the NEC and it may not function.
Yeah, I mean, I love so your background fuses, right?
and
On
breakers.
primary transformers,
Oh,
300%.
Yeah.
Right.
Oh, yeah. Up to 300% and 250% on primary if it's a circuit breaker.
But why is it allowed to be oversized? All the transformer
Inrush
inrush, right?
grids, absolutely.
Which now, if I want better protection, I put a breaker and I do monitoring on the low voltage side of the transformer versus the high voltage. Right?
Yeah.
We get into all those
There's
discussions.
so many things you could do to
There is.
read designed the system to address the high incident energy from the breaker integrated transformer, right? My favorite product, the breaker integrated transformer. Oh my goodness.
It's a great idea. I don't know who came up with the idea.
I don't know. I'll tell you, and when I learned about it, so I was actually talking to a customer who manages the safety for a very large automotive facility. I asked him, what do you lose sleep over? And he said, Tom, honestly, from a safety perspective, what I worry about the most is that first piece of equipment on the secondary of every single transformer in my facilities, because the energy is so high, and they have a lot of isolation, one-to-one transformers in their facilities. So, and it's a panel board. So as an electrical worker walks up, they're just thinking they're dealing with the average, normal, everyday panel board. So then we came up with the idea. We said, wow, why don't we integrate it? And Scott Brady was there with our engineering services. And what I love, I said, hey, what if we put the breaker in the transformer on the secondary? And so Scott was like, yeah. I said, well, I'll talk to the product line. And then Scott goes, well, if the product line doesn't do it, he says, I'm in services. We'll do it. We'll get it listed because services can do that stuff, right? And I mean, that's the great power of our engineering services division. If we need a solution that maybe it doesn't exist, they'll make it. They'll make it. And then I went back home and I sent an email to the product manager for transformers. And I said, hey, did you ever think about this? And he goes, Tom, we've had that for a few years now. And I'm like, oh my goodness, where have I been living? So that is an absolute awesome product.
So another story, you just made me think about it. I was at a car manufacturer here in the U.S. I won't give you the location. That would give the name away. But showed up for the training, and I said, Monday morning I always meet with the manager and say, okay, I just want to make sure I meet all of your expectations for this training. What do you want to see as the outcome? And the manager said, Mike, see this cardboard box over here in the corner? I'm like, yeah, because that's a remote racking device I bought for the secondary breakers of those transformers.
Oh, wow.
The incident energy is sky high. They can't operate them. I bought this device. I have no clue how to use it. My guys, they just let it sit in the box.
Yeah.
I said, we take care of that.
We could take care of that and so much more.
Oh, absolutely.
Absolutely. Because once you start getting into education, you just scratch the surface, and then you start realizing I'm in a target-rich environment to help someone and make people smarter at what they do. Because that's your sphere, because you have your sphere of knowledge. You may bring somebody else to that same site who has a sphere of knowledge and then be able to educate them in a different area.
So Bob Haltz, I'm sure you know Bob, he's up in Maine, right? Works for services, does a lot of training for my team. He actually was in Warrendale a few weeks ago, and he drew a circuit up on the whiteboard. He said, I got a question for you. I said, what's that? He goes, first, what is this? I was clueless. Had resistors everywhere, some in parallel series. It was the resistance going through a medium voltage switch with parallel blades and the connection point of the flicker blade and all that. And then he said, all right, I'm going to put a ductor across this switch while it's closed and measure the resistance.
Yes.
And I said, okay, I'm on board. He goes, so if this resistance is high, you can't tell me it is. If this resistance is high, you can't tell me it is. And he went through and he eliminated like 10 loose connections.
Wow.
And said, in your measuring, you can't actually measure this.
Wow.
I sat there and I said, yeah, you're right. I learned something,
Interesting.
right?
Absolutely.
Which is why
right.
we then not just do ductoring or resistance measurements, we do IR scanning too.
That's right.
Because we picked it up on the IR scan. One side's hot and the other's cold.
Yeah, and you may not have measured it.
Right.
Yeah, absolutely.
So, I mean, everybody has their little sphere.
Absolutely right.
And that's the thing.
And you know what? As I look through this whole facility here, there's little spheres of knowledge being shared in every booth and at the food over there, at the bars over there. There's just a lot of knowledge being shared.
And you can't look at a person and even begin to take a guess what their knowledge is.
No, that's right.
I mean, right? They're all so unique and they all have so much knowledge to share. So
Absolutely.
I love coming here every year.
Yeah, absolutely. Me too. Me too. This is cool.
Yeah, absolutely.
You are the man.
So one more thing I got to say. So we focus a lot on in-person training. COVID is kind of winding down here, right?
Right.
In-person's coming back. So if you go to the webpage, eaton.com/electrical worker training.
Electrical worker training.
You'll see in-person training with a whole bunch of standard courses you can register for. We do all the customized courses though too. We have remote instruction, so if you still don't want to travel or you're looking for a shorter class where you
Yeah.
can sit at home,
Okay.
maybe in your recliner,
Maybe.
right? Maybe having a beer, I don't know.
Oh, you never know.
You can do that.
Yeah.
We also have our e-learning,
Oh, that's right. Yeah, e-learning. Yeah.
so you can take self-paced classes
Excellent.
anywhere from about an
Can you
hour to
get
5 hours.
Can you get PDH certificates or anything like that through those?
We can offer CEUs for any of them.
Oh, wow.
Not a problem.
CEUs.
CEUs, yep.
Yeah, now, and I know sometimes some states might have a little, like, if it's a contractor who's in Ohio, they might have to go through the Ohio Board of Building Standards. So you always have to question and make sure you understand where you're located to know whether or not that CEU would be
Yeah,
accepted.
and it's kind of weird. We use the local community college in Pittsburgh, and I get asked all the time,
I
why?
know. Yeah.
Why that? Well, because community colleges are generally accepted in most states.
I did not know
That's
that.
the reason, yeah.
Interesting.
So there is a thought process behind it.
You're talking to the wrong guy when you think about thought process. Okay.
So we have that e-learning, and we are in our beta testing right now with a customer doing virtual simulation.
Wow.
So this is something we rolled out internally. It started about 2 years ago, where we have our own field employees take tests on how to create electrically safe work conditions.
Well, that's awesome.
Right. Well, we've now actually sold that to a customer of ours, and they're being the first ones now to walk through that, and we're actually modifying it and making it for them. So to the level, their PPE, when they choose it in the simulation, actually says their name on it. It has their logo on the PPE, right?
Awesome.
Their job safety analysis. It's not our form or some generic form. It's actually their form.
That's
And
awesome.
they're telling us their expectations of what an employee has to do a successful JSA. So we're taking it to that level of customize even a simulation.
That is awesome. So a lot more to come from Eaton.com/electrical worker training.
You got it.
You're the man.
All right.
All right, brother. Michael, thank you.
Hey, anytime. And if anybody didn't see the LinkedIn, his signature worth $1 million.
Absolutely, $1 million. But free right here in the booth today.
Absolutely.
You're the man.
All right. Thanks,
Thank
Tom.
you, Mike. Awesome. Awesome. Well, that was a lot of fun. Mike is a dynamic individual, very knowledgeable, and we focus a lot from an Eaton perspective. That's a part of our core, in my opinion. Hey, John McCoy, that is the biggest microphone. Yeah, baby. What do you think, man? I tell you, go big or go home. That's my motto. Absolutely. Ah, man, I can't lasso him in. Gotta love it. So, Charlie, where's our PPE person?
Looking for her. I'm gonna talk to her.
Yeah, I need to get her on video.
You need to talk to her.
Yeah, we want to get her on video. Yeah, we're going to talk personal protective equipment. That's another relatively new solution that Eaton is working on or has to offer to provide. Oh, man. All right. We almost had our PPE person. So, personal protective equipment. So we have 40 cal outfits that are comfortable to wear and state of the art. We have gloves and tools also that we're offering. You know, we provide the equipment, and I always say my goal is to get our electrical workers into daily wear. We have the overcurrent protective device solutions. We have the arc flash reduction solutions. We have all of the right technology that, from an arc flash perspective, we can mitigate and reduce the incident energy to get you into daily wear. And then your biggest hazard that you have to worry about and think about is shock. So my goal is to put that 40 cal outfit that's over there out of necessity by overcurrent protection and technologies to reduce the incident energy. So please be mindful that personal protective equipment is a last resort, but it is a necessity for when you are establishing an electrically safe work condition. You're still going to need to dress. In my opinion, I don't believe there's any such thing exists as work that's conducted in an electrically safe work condition without actually dressing to verify absence of voltage. So my point there is you still need to dress for success. We provide some of the best in the industry, so you're going to have to check out our PPE offering from our Busman division. All right, John McCoy, thanks for tuning in. Ryan Jackson, thanks for tuning in, and all that jazz. Yeah, John, I got a new microphone, which is a wireless microphone. If I take this off, you'll see it's a small mic that's in there, and this is just holding it for me. I'm wireless. If you watch the videos from last year, we had some lighting issues, we had some audio issues, but we're getting bigger and we're getting better. So always working through the challenges of, and I know he's going to hit my my camera. All right. So Jody Wages, come on over. Oh, okay.
I want you to have them. You remember?
Yes. Perfect. IEEE. That was Jody Wages. Jody is in his booth. He's the only one at his booth, so he can't come in here right now. Jody Wages. This is a window sticker for the truck, and IEEE does a lot of focus on electrical safety and training. They are electrical safety leader. I'm on the board of directors for IEEE, and we are doing what we can to help increase electrical safety through education. So if you go to IEEI.org, I would ask you to go take a look at that. Take a look at their YouTube channel. If you search on YouTube for pound IEEI News Live, all one word, and I say pound, I think they call that a hashtag or something like that. But go check out pound IEEI News, hashtag IEEI News Live, and learn more about what's going on their YouTube site as well. And subscribe, please hit that thumbs up on their videos and subscribe to their YouTube channel. It's free, it's educational, and it's everything that we do to help increase electrical safety through sharing knowledge. That's what it is all about. All right. So we talked automatic transfer switches. We talked about our monitoring solutions. We talked about 70B. We talked about, we have the as Mark Elliott was taking us through the booth earlier. We talked about the safety disconnect switch that's on the other side of this wall that basically has some ground fault protection of equipment built in, and an arc reduction maintenance switch. Ground fault protection of equipment is required for services 1,000 amps and above, section 230.95 of the National Electrical Code. That switch that's in this booth is a 400 amp switch. It would not need to have an arc reduction maintenance switch on it. It would not need to have a ground fault protection of equipment, sensors and relay inside, but we build it in because it provides value. If you have ground fault protection of equipment closer to the load, then you can achieve a coordination and not take out the main for ground faults downstream. If you have an arc reduction maintenance switch, arc reduction incident energy is not dependent upon necessarily the size of the switch. I could have a 600 amp switch, a 400 amp switch, a 1200 amp switch, a 3000 amp switch. I could have high incident energy because it's about two things. It's about how much current, what's the arcing current flowing through the circuit, and what is my trip time. And if I have low fault currents on specific overcurrent protective devices, I could have high incident energy, even on a 600 amp or a 400 amp switch, or a 400 amp downstream of a 400 amp circuit breaker. It's all about the incident. It's all about the available fault current and the arcing currents that result. So you can benefit from an arc reduction maintenance switch to reduce the severity. You can't reduce the likelihood of an event, but you can reduce the severity of an event by employing faster technologies that will clear the arcing faults faster and reduce the incident energy. Excellent. All right. I'm telling you, there are a lot of individuals walking around the booth. They're eating and they're enjoying each other's company. And we've got a little bit more time to go. So I am going to get a drink of water. So what I'm going to do is I'm going to put you on pause, and I'm going to grab something to drink, and I will be right back, so stay tuned. All right, so I was on my way to get a drink of water, and look who I found. Derek Vigstall. I know this guy, and a lot of people out there know you as well. Tell them who you are.
My name is Derek with a D, Vigstall. I am an electrical safety consultant for eHazard now. Formerly spent a little bit of time at the National Fire Protection Association doing my thing there, but now I'm living the dream over on the other side as in the private sector, doing training, doing ESP development, doing electrical safety audits, all that fun stuff that was right up my wheelhouse, you know.
Absolutely. So you're traveling across the country now and working with
internationally too.
Oh, really?
Yeah, I'm headed down next Friday. I leave for Suriname, Paramaribo, Suriname, to do.
Wait. Paramaribo, Suriname? What's that?
Suriname. Yeah, it's a country. It's down a little bitty country on the northeastern coast of South America, in between Guyana and French Guiana, and primarily a mining colony. But
and you're talking electrical safety?
I'm running down there to do a train the trainer for both low voltage and high voltage safety, and I'm running their guys through an 8-hour class on low voltage safety, an 8-hour class on high voltage safety, and I'm going to get the whole plant plus train their engineers up so that they can do it next time. And if I'm lucky, maybe I can get into the jungle and catch a giant Amazon or giant South American catfish. That's what I'm.
Oh wow! Giant South American catfish.
That's
what do they walk on land?
No. There's rivers there, and they swim like American catfish. Like it's not that different.
What language do they speak?
Dutch.
The catfish speak Dutch?
Yeah, it's crazy. Actually, fun fact. I think when I was down there last time for NFPA, the official language of Suriname is Dutch, but they recognize 13 official languages in the country.
That's incredible.
Yeah, so it's like
you have to speak electrical safety in 13 different languages. That's going to be great.
No, I can't. I can barely speak it in one language.
I love it. So tell me, how long have you been coming to the Electrical Safety Workshop, and why?
So this location here at the Pepper Mill is anniversary of my very first ESW when I went to NFPA, and I think that was what? I don't know.
You know what? Thank you.
Yes.
Thank you. Because everybody else I talk to, they'll say, oh, 2013, 2005, 2008. I can't say when my first event was. I couldn't even tell you what hotel I was in.
It's been a while.
Yeah.
I do know it was here though, and that was back in a different lifetime ago. But yeah, I've been coming to the ESW for a number of years now. It, in my mind, is the premier electrical safety event,
bar none.
I mean, hands down. It is like, you know, people tell me all the time that that I do a great job with the training and all that, but like, where do I go to get trained? Here. Yeah,
so
like, I need to learn stuff myself. I need to learn.
Okay, so
yeah.
So where does it happen? Does it happen in there on the PowerPoints and the presentations, or does it happen out here? Where at this event, where do you think, in your opinion, where does the most transmission of knowledge occur?
Yes.
Absolutely. I love it. In there, out here.
I'll over-engineer you. I'll say it depends. It depends. No, so it starts in the sessions, right? And you get the presentations, and you see these impactful, very knowledgeable people delivering the information, right? And then you pair that with reading the papers that they provide for you on the app, and you download all that stuff to get all the really good stuff,
right?
Because in a 45-minute presentation, your hands are a little tied on what you can do. So you get all that stuff coming here, you read the papers, you see the presentations. Now I come to these events and I chit-chat with people and I network and I talk to people. Like, what did you think about that presentation on, just case in point, the one on the checklist for the DOE.
Oh, yeah.
Stuff, right? Like, as on face value, I read the paper and I'm sitting there listening to the presentation. I'm going, well, this is great for DOE, but how do we apply this to other places? And then I talked to Bill Harris from GM, and he's like, oh, no, this is going to be great because now all this stuff that we got coming into the plant that's non-NERDL listed stuff, and we have a process for it now, and we can give the AHJs something to go on. And I'm like, I didn't really think of it that way. And I'm going, but that's the value of coming here because
you have the dialogue. So like you say, you have that presentation, you have in your mind, maybe you question and go, I don't think it was that valid. And then you talk to someone else that goes, oh no, it was. And then all of a sudden it puts a whole new light on what you just saw.
Yeah, and it's just like, it's just a completely invaluable educational experience.
Absolutely right. I agree 100%.
Like I wouldn't miss this for the world.
Yeah.
Unless I had a family thing. If Katie told me I couldn't come, sorry, I'll see you next year.
Absolutely right. Yep. Absolutely right.
Yep. But
so that's awesome. Are you going to take Katie to the island?
Suriname?
Yeah, I don't know.
An island.
Oh,
although it's kind of an island.
Yeah.
It's still in the Caribbean nations.
That's what, the way you described it. I'm thinking island.
No, I'm not taking her there.
All right. All right.
We just got back from Dominican Republic.
I saw your videos there. That was cool. So here's the other thing. Connect with him on Facebook, on LinkedIn, and you're not on YouTube again. And I know you were on YouTube with NFPA. Are you doing that at all?
No. So hold that thought. But so when I came over to eHazard, I mean, I kind of wanted to do all the stuff that I was doing at NFPA before I came over to eHazard, and with as busy as I got doing the training and the audits and the ESPs and stuff like that, it as you know, it takes a lot of time and it's a big commitment. And also, I don't want to like dip my toe in the water and then have content go stale, right?
Yeah, no, you're right.
We did start a podcast called eHazards Plugged Into Safety. If you want to check it out, I think it's on the Apple Podcast and
excellent.
It's wherever you get your podcasts.
Wherever you get your podcast from. What's it called again?
eHazards Plugged Into Safety.
eHazards Plugged Into Safety. Yeah. So check it out.
And too, if you guys got ideas for us to do podcasts, I mean, we're more than happy to. You can send us an email at podcast@e-hazard if you want to say, hey, you know what, we'd really like to see you eHazard guys talk about.
It's great.
Blah blah blah.
Blah blah. Oh, I've always wanted to learn about blah blah blah. Yeah. Blah 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 is very. It's an untapped issue in the industry.
By the way, expect a public input from me to Article 100 to define blah blah blah.
I look forward to your public input. That's perfect.
Hey, look at
excellent. Come on. So here's
this guy behind the camera.
Yes. So here's another individual, very important. He too wears the button of mentoring. Come on. Yeah, there it is. Come on over. Yes. So.
Hello.
Hello. Welcome. Welcome
Thank you very much. I've never been on live streaming my entire life. This is the first time.
Oh my goodness. This is we've got a rookie. This is a magic moment. Well, I'm glad that it is with our Eaton Tech Talk.
Oh yeah, and I freeze up and I cannot say anything when I go live. I don't have that public appearance that you two have.
Oh, so you're really.
Did you hit makeup before you came?
See?
Yeah.
I didn't even know that was.
You didn't even know there was makeup?
No.
Oh man.
I didn't.
So tell me, I know you're involved with the Electrical Safety Workshop heavily. What do you do for the ESW?
So my role is after all of these papers have been published, I make sure that I reach out to the authors and we try and get subject matter expert peer review through the IEEE system. So you got the conference review that gets the papers in, and my job is after that review, once the presentations are done here, and all of the papers are uploaded into the Explore
That's my
system.
job.
That's your job.
I know. Sometimes I'm a little slower than I should be.
So I was the one sending you 102 emails last year.
Yes, and they quickly went to trash.
And you delivered on them. Thank you for that.
Sure.
So basically, we have a copy of all the papers that are published here at the conference.
Yeah.
We've got the proceedings from the conference that are uploaded. What I do is I take those proceedings and we send them for peer review through subject matter experts.
Right.
We achieve two things with that. Number one, we get the reviewer scores, which goes towards the paper nominations, the best paper award, honorary mention award. But more importantly, we get subject matter comments, which improve the quality of the paper, improve research and development, eventually advancing this electrical safety culture.
I love it. That's our job, to advance electrical safety culture. And it takes many years to change a culture.
Right. So in addition to the papers, I'm also on the organizing committee on the technical paper review. So I help Dennis Hill make sure that we get adequate reviews of the paper during the initial stage when the draft paper comes through. And we get enough eyes on that. We help the authors get their formatting correct, get the PowerPoint presentation on time. And for about 60% of those, we're successful. And sometimes we get the presentations early in the morning. So if you're a future ESW presenter, please get your material at least 2 months in advance. It really helps us get a smooth conference going.
It absolutely does. And you will be involved with next year's ESW as well.
That's the intention, and to also be learning for what you've been through as chair. Because 2025 sees me coming in after Jay. So
you're another future chair.
That's right. Yeah.
Okay, so so next year is in Tucson, Arizona.
Right, and then 4th to 8th March 2025.
Yeah.
Jacksonville, Florida.
And that's where I was chair. I was chair for the Jacksonville, I believe it was Jacksonville, Florida. Yeah.
Wow.
That's awesome.
Yeah.
I love it. I love it. I love it.
So I'm going to get all the tips about what are the nice fun spots in Jacksonville.
Yeah.
And I don't know why I say that, because
as chair, you don't get a chance to do anything.
So I've been attending this conference for, I don't know, probably since 2015 or so.
Yeah.
And I've attended every year since. And there was only 1 year that I was able to step out of the hotel.
I know. It's
1 year.
Absolutely right. Absolutely right.
And that was...
And that was probably because...
ESW, that really the only fun place in Jacksonville that week is at the Hyatt down on the waterfront where ESW's at.
That's the truth.
I mean, where would you rather be?
That's the truth. And the event that caused him to leave the hotel was probably somebody pulled the fire alarm.
Well, that's good. At least it worked.
That's right. At least it worked. Yeah, we tested it out. So you are a long time. What was the reason you came to your first ESW? Do you remember?
Yes, I was doing research on electrical accident investigations and how effective those investigations were. So part of my research, I started asking a few people questions, and the chair of the 2015 Louisville conference said, wow, this is pretty interesting. Why don't you come over and talk to us about this? So I said, I'm in Johannesburg, South Africa. How does somebody like that get over? And I said, well, if you're serious enough about this, you make a plan. And so submitted a proposal that year, was accepted. So the first time I attended this was as a speaker.
Wow! His first ESW was a speaker, and his first time on TV is with us.
Yes.
And he's full circle. It's full circle. That's awesome. That is awesome.
Yeah. So enjoy, have fun, and that looks pretty high definition. And
yes,
let you two continue. Your
so both of you are on the same, work for the same company.
It's actually my employer. Yes.
I'm not. I'm the technical guy. So Hugh Hoagland who's done so much for the electrical safety fraternity.
Yes.
Retired last year.
Yep.
And he took his retirement pretty seriously. So,
Oh yeah, I still, you know, he commented on a few of our posts. So Hugh, if you're out there, we miss you and we wish you were here. So we miss your dynamic speaking and all the great stuff.
To come back.
I'm tempting.
I'm really enjoying watching the retirement. He is setting my like goals for retirement as I watch him on all the different.
He's on the bourbon trail.
Yeah. Well, I don't drink anymore, but he's doing his thing. But all the scuba diving, all the travel, all that fun stuff.
Oh, he is. Yeah, that's awesome.
And do you know what? When people contribute to our goal at the end of the day, all the best to them.
Absolutely right.
You know, all the best to them. And Hugh was able to be a mentor to so many people. Even one of the presenters mentioned his name today.
Yeah.
And people like him, people like Jim White, and several others. I mean, let me not start mentioning names.
Yeah.
But to all of those that have have been involved here, I mean, really, we stand on their shoulders, right?
You're absolutely right. And hopefully one day people will stand on your shoulders because of your commitment and your involvement with the Electrical Safety Workshop. I appreciate everything you do and you do for the industry.
And I must say, and I follow the both of you because he does a podcast as well.
Yeah.
And I follow you as well. So I learn a ton of stuff. And it's sometimes I'm working and I've got you playing on the background there and I'm watching you. So I think from my side personally, you know, thank you for everything that you've done. And what a lot of you don't know was that Tom was chair of ESW last year.
Yeah.
And normally this takes about 24 months to prepare. You come in, you see what everyone's doing, then you spend a year kind of figuring it out a little bit more, then you do all the organizing. This man came in, what, like 3 months before?
Yeah, it was something like that. It was fast, yeah.
This is legendary.
No, it speaks to the team. It really does. And as chair, as a future chair, you're going to see. And you know, because you're a part of it. And it's a lot of work. It's spread out with a lot of people, and everybody here is enjoying the benefits and the fruits of a lot of work from really a small number of people. But we would not have that if it wasn't for everybody that was here. You know,
it really is a group effort. I mean,
yeah, absolutely.
I mean, as much credit as the chair will get, right? There's a lot of people that are behind the scenes making this thing happen.
Absolutely.
It's good you mentioned that. I want to say this. Mark Scott, you rock. Awesome conference. Thank you so much for everything that you're doing. Appreciate it. Tom, appreciate you. Derek, appreciate you all.
Thank you. Absolutely.
See you all, all right?
Thank you, sir.
Good.
Excellent.
See you all.
Awesome. What another opportunity.
And you know that story about you just kind of stepping in for the chairship? It reminds me of another story. I heard, didn't you like go sit for your PE with like completely without studying or something like that?
No, I'll tell you. So no, what happened on my PE? Oh my gosh. So I did study a lot, right? So I studied, and I got up in the morning, and it was in Pittsburgh at the convention center. So I got up. Bobby Joe says, "Do you want me to make breakfast?" I'm like, "No, I'm just gonna go. I'll get coffee down there and whatnot." She made me a little lunch. So I get in the truck. On the way, I hit a deer. Okay, so I hit a deer. The deer's on the side of the road. Police have to come. They have to put the deer down, and then he takes a picture of the truck, and then I'm like, I gotta go, right? So now I drive into Pittsburgh. I grab my books. I hike it up in through the convention center. I go to the room that it's supposed to be in, and it says it was moved to the other side of the convention center. Okay, now and then the only way to get there is I got to go back down to the parking garage, go across the street, go back up. When I walked in, they were about to close the door. No coffee, no breakfast. All my plans were done. I walk in, they sit me down at my seat. I put my books out, and I'm sweating. I'm exhausted. And then, so I studied with a gentleman who was taking his test in West Virginia. So we take a break, and I come out, and you're probably not supposed to do this, but he calls me and he goes, what kind of questions do you guys got? So we're exchanging some of our experiences, and he's mentioning test questions that that. I'm like, well, I remember that one. Yeah, I had something similar. And he said what he put as an answer. I'm like, no, that's not what I put. You know? And I'm like, oh my goodness. So now, and afterwards, I talked that evening. Now I have to wait months.
Right.
So he calls me and says he got a package from West Virginia, and his package was like 3 inches thick. It had all of this information. He thought it was on how to reapply, but it was how to get your PE framed and all this other good stuff. I go out to the mailbox, and there's this little letter. It's as thin as a piece of paper. It's all it is. I go walking in, and I'm like, oh my goodness, all that studying and a bad day. I told Bobby Joe, I said, you open it. I don't want to open it. So she opens it, and it had one word on it: pass.
Yeah.
Oh my gosh. Totally different than how West Virginia did it.
It just shows you work really good under pressure.
I work good under pressure. That's
Everything's falling apart.
right. And I performed.
You still pass your PE exam.
I know. Oh my goodness.
Not like us silly electricians. We need everything perfect, and then we go sit down for our master's test and we still fail.
Well, this comes from the guy who aced, I'm saying aced, the NFPA NEC challenge at one of the annual meetings.
Yeah, I might have had fun with that.
Yes, you did. Jeez.
Yeah, that's what got me to NFPA is the challenge. And so when I think back, I mean, I've been extremely blessed in my career, and the opportunity I've had to be able to do things and help the industry and give back some of the knowledge that I've learned over the years. And it really, when I look back, that was the turning point. Like I was loving my job at the JTC in Minneapolis, teaching. I mean, I was having a fantastic time there, and I didn't even know about the challenge. And somebody just said, "Hey, did you take the challenge?" And I'm like, "What challenge?"
Yeah.
And and it worked out for me. And
the rest is history. I knew it. I knew it.
I loving every minute of it, and
that should be a song.
Yeah, I think it is. Yeah. But I mean, you and I have become pretty good friends over the years, I would say.
Absolutely.
And I mean, I value our friendship, and I look back on it like, if I hadn't so like the whole background story of how I even took the challenge.
Yeah.
Was I'm sitting on the bus at NTI for IBW, and I'm sitting on the bus. I'm looking around, going, everybody's got these cool Milwaukee bags. I don't have a cool Milwaukee bag. What the heck? Why didn't I get a cool Milwaukee bag? At that time, I had been there for like 4 days already, going through OSHA 500. I built her 510.
Right.
And so my brain's just mush, and I'm like, why? Everybody's got these cool Milwaukee bags. And I'm like, so I lean over to one guy on the bus and say, hey, where'd you get this Milwaukee bag? He said, oh, you got to go sign in at the trade show. I said, there's a trade show?
Oh my goodness.
And he's like, yeah, there's a trade show, and you have to go get your stuff. You have to register there.
Yeah.
Okay. I said, when is it? They're like, it's the next stop. So we did the e-stop cable on the bus. I jump off, I run in there, and I'm like, I need my Milwaukee bag. They're like, here's your Milwaukee bag. And then one of the teachers I taught with at the JATC in Minneapolis comes up and goes, did you take the challenge? And I'm like, challenge? I mean, this is working out pretty good for me so far. I'll keep rolling with it. And and I thought it was just going to be an iPad, but turns out it was a job and a absolutely fantastic career.
That is absolutely awesome.
Yeah.
That's awesome. That's a great story.
Good evening, everyone.
Uh-oh.
You're having a good time. I give you a notice that for the next 15 minutes, you'll need to turn in your passport.
Oh, this is the passport. The passports.
15 more minutes, and then we'll start the drawing.
They do the passport, they do the signatures, and then you have a chance to win a prize, which is probably an Eaton T-shirt.
Well, I think
no.
I think like there's some pretty decent prizes.
There sure is. Yes, there is.
I in past ESWs, I don't know what we have here for this one, but in like past ESWs, I think there was like AirPods and some pretty significant prizes. So if you're watching and you're here at ESW, get your passport filled out and get it over there and get it entered into.
Absolutely, and you better be watching even if you're here at ECSW, so you can be walking around and looking at the at your phone.
Right,
But just don't walk into anything.
That brings up a scene from Spaceballs where he's looking in the monitor. He's looking,
Yeah, it was. I love it.
it's the line he says there.
I love it. I love it. I love it. Well, that's awesome. Thank you.
Get back to the booth, and
All right,
'cause
Derek.
people are going to be wandering by needing their passport signed. So
Absolutely.
sign some passports.
Get over there. Don't forget
right.
your plate.
I won't. Take care.
Take care. All right. Well, let's see. What time is it? Let's see. We got John McCoy. It is 5:30. All right, and they're going to start doing the drawings for the passports. So hopefully you're getting a little flavor for what's going on here at the Electrical Safety Workshop. At the Eaton Booth, things are hopping. We got a lot of good conversations going on all around, talking personal protective equipment, talking arc flash reduction, talking 70B and education. So we've got a lot of great things going on here at the Eaton Booth at the Electrical Safety Workshop in Reno, Nevada. So hopefully you're getting something out of the conversations and a desire to come to the ESW next year. And if you come to the ESW next year, you got to stop by the Eaton Booth and say, hey, Tom, I want to go live, and I'll take you live. All right? So I'm going to, we're going to pause for a little bit because I have to get some water, and we'll talk to you in a little bit. So please stand by. All right, so we are back again from the Electrical Safety Workshop, and we've got two more victims. Yeah, slide in over a little bit. Slide over, okay. There we go. All right, so why don't we tell everybody who you are. That's the camera. Okay. So that's the screen that we're all looking at, but that's the actual camera. Sometimes I tend to look at the screen as well. So give us a little who you are and all that jazz.
My name's Rick Mayday. I'm based in Arizona.
Arizona?
I cover the western states. States. I'm a sales engineer for the West Side. I'm a specialist in wiring devices.
Oh.
I've been in the electrical business for about 35 years, a little more maybe.
Okay.
And that's my story.
All right, excellent. And?
I'm Chuck Gelderts, also on the wiring device side, and I'm the area sales manager for the Western region.
Western region. So we got the Western region covered. So what's new in wiring devices? What are we showing off?
Well, we've got a whole number of things. I mean, we're coming out with new disconnect switches, motor disconnects, non-fused.
Okay.
We have data center locking devices rated at 415 volts, which are kind of interesting. Those are NEMA devices, not IEC.
Okay.
We have a whole series of new versions of GFCIs and surge protection devices. Chuck, what can we add to that?
Yeah, the GFI that's coming out, we're doing a completely new redesign of the GFI. So it'll be a much slimmer design, so it'll fit into the box much easier.
Oh my goodness, yeah, because those GFCIs are so deep.
You can crank those things in there, right?
Oh
You
my
want that in the
goodness.
box.
Yeah.
It's going to be about 30% slimmer than our current design.
Nice.
The front of it's going to be much sleeker, and it has an end-of-life button and a reset button with light. So it lets you know, the homeowner, the end user know, if it just needs to be reset or if the whole device needs to be replaced. It's very simple.
Interesting. Now, all of our GFCIs, do they do the self-testing?
Correct.
That's required by UL 943.
Correct. Yeah, every GFI device that we have, whether it's dead front or an active device, it checks itself every so often, and if it's bad, it shuts itself off.
Oh, it does. That's awesome. That's really cool. That's really cool. So it'll let you know that now. Does it actually open if it does an internal check?
Correct. Yeah, when it does the internal check and it finds out that it's not working anymore, it kills the device. You can't reset it, and the device is dead.
You replace
it. So you don't have, you have to replace the entire device.
That is awesome. You know, I always test my GFCIs. Did you test
You do.
Yes,
You exercise them.
Did you? Let me ask
God
you.
bless you.
Are you staying in the hotel?
Yes.
Did you test your GFCIs?
I did not.
Oh my goodness! I test them all the time. And here's what I do. I usually carry stickies. Because I will find GFCIs that don't work, and I will put a sticky over them, and I'll say, please replace. Not functioning.
That's awesome.
Yeah, because I'll press the test button, and they're older. They won't trip.
I don't plug anything in at the hotels because my hair dryer is battery powered.
Yes, I have the same hair dryer.
One of the things that we did recently that was, not a huge change, but it was interesting and it's gotten a lot of talk, is we've taken our NEMA locking devices.
Okay.
And we've color coded them per the NEMA standard.
Right.
And why did we do that, Chuck?
Absolutely. I love the color coding. It makes life so easy to determine what they're. Now, the colors tell you the voltage.
Right. Yes. Right. So it's a clear line.
And it's visible.
And it's black is 600, blue is 250.
Yeah, and it's not hidden when they're connected.
Right.
And I know some do the colors, but when you plug them in, you can't see the color anymore.
Now IEC has been doing that for decades, right?
Yeah.
So and everybody thinks it's something weird.
You'd have that tiny little circle. Like I said, as soon as you made it up, you're not seeing that circle anymore. So
exactly.
But yeah, with skilled labor going the way it is, having stuff that's somewhat dummy proof, right? That people can just say blue goes to blue, red goes to red. It's simple to do.
Oh my gosh, you ought to put animals like geranimals.
I know. Yeah. Another thing that we're doing is on the pin sleeve.
Yeah.
And Chuck's more privy to this than I am, so you might want to chime in. But we're taking the IEC 60309 pin and sleeve devices and making them compatible both with European amperages and North American amperages in one unit. So 30 and 32 amp.
Right. That is so nice. I'll tell you what, I just recently went over to Bonn, Germany, and I was over in Vienna. Okay. And oh my goodness, the receptacles over there are so different.
Yeah.
And they're inset. And there was a picture in one of the slides. So I had to have an adapter to an adapter to an adapter to get my computer to plug in.
So then it's dangling down. Yeah, everything's.
Oh my goodness, it was terrible.
The leaning tower of outlets.
The leaning tower of outlets. I love it. That's cool.
Yeah, so it's great because with data centers going up around the world, there's different standards all over the place. So having the dual rated pin and sleep
makes a lot of sense.
Oh, absolutely.
Eliminate the skew. sense.
Yeah. Oh, that's really, and it's efficient for us, but also it helps the customer.
Absolutely. Yeah.
I love it. Yeah, I love the color coding. And I saw that at one of the trade shows, and I was just floored.
Yeah.
And it's the simple.
Right.
It doesn't have to be big technology.
Right. No, it doesn't. No.
Yeah.
Change. The last thing we want to talk about was the surge protection. So we've got a couple different things that go into the panel that you can that a basic electrician could do. Put it into the panel. So you get surge protection right in your panel. Or you can put a TVSS device in the wall. So you plug your TV or you put in sensitive electronics, and you're surge protected right there. So you don't have to have a big strip laying on the floor and have a 6-foot cord.
Yeah.
It's just right there in the wall, very clean. You plug your TV in. It's nice
And you have the LEDs that tell you the yes.
So in the 2020 code, if you will, you're looking at type 1, type 2.
For service.
Right.
Yep.
And we provide a lot of solutions for type 2.
Okay.
From the panel on through the circuits.
Right.
Now, but at the end of the circuit, a lot of surges are generated within a building, right?
Absolutely.
And the whole reason for surge being put into the NEC is for first responders, right? If something's burning, something's happening,
Yeah, you want the smoke detectors to be functioning.
Right.
You want the AFCIs to be functioning, the GFCIs.
Right.
So, and it's a tiered approach.
Yeah, exactly. So I suspect down the road, eventually the point of use units will get worked into it in a robust way.
They have to, because in my opinion, and we all know this, IEEE tells us you need a tiered approach. You need to knock the surge voltage down at the service, and then you knock it down even further at closer to the load, because when you get to sensitive electronic equipment, you may have knocked that surge peak voltage that's fine for up at the service panel board, but when you get down to those loads, you need to knock that down even further.
Yeah, exactly.
Yeah.
And that's a safety thing. And it's new. That's a new thing. Right.
Absolutely right. Yeah. And the code is just now, the other issue I have, we talk about life safety and surge, but the NEC in Article 90 for the scope and the purpose of the National Electrical Code is about life safety and protection of property.
Right.
So if I have a lot of property loss, which surge issues can create a lot of property loss, that's another reason for a surge protective device. It's not just about life safety. We tie it to life safety, but in reality, if I lose millions, if I lose I have hundreds of millions of dollars of loss because of electricity, that's ungood too.
Yeah.
So,
if you can save one life, that's great. But if it saved $10,000, that's better.
Well, here's the thing. I talked to a very smart individual at he's head of safety for an electrical contracting, a very large contracting firm. And I asked him, his name is Harvey. I said, Harvey, his safety program is funded very well, okay, from his company. He has great educational opportunities. He has safety directors at all of the facilities. And I asked him, how are you so successful? And his answer was, he says, look, I talk two ways. When I talk to my guys and my gals in the field, it's about going home, it's about saving their lives, it's about protecting their livelihood. He says, but when I talk to upstream, to business, it's about the dollars and cents. Yeah. It's about how much money I'm saving the organization. And unfortunately, you have to talk that way because everybody has a different appeal, right? And we live in a society that's just a reality.
Right.
It is a reality. It's a fact. So I can save lives, but if I can save property, depending on who I'm talking to, it's a great message. Right. So.
Well, it seems like the likelihood of somebody getting hurt in a home is less than the equipment being hurt in a home, right?
Right.
People aren't sticking their fingers in light sockets. People aren't doing those kind of things, really. So we have those life safety things that we take for granted. But you're plugging in a $1,000 sewing machine, and a little surge comes in there, and that thing's gone because it's so sensitive, right?
You're absolutely right. Or all of that communication equipment that you have, your TVs. And I always tell electricians, look, you go into a house to change a light switch or put in a light fixture or maybe a ceiling fan. You should Test those GFCIs while you're in there.
Absolutely.
Press all those buttons. Do a safety overlook for the homeowner. Explain to the homeowner why it's important, and take a look at all of that expensive equipment they have, and tell them, look, we can help protect all of that by putting in surge in a tiered approach down there at the load and in there at the service.
Absolutely. And when you look at the code and the progression over the years, I think arc fault protection began in the bedroom 30 years ago.
Yes, that's right. Yeah.
And that was a good choice, right?
Right. Yeah.
And now we have it in the kitchen. We have it in all these places.
Living room, dining room.
Just like GFCIs. So really, what we're watching is the morphing of the descriptions of the application. Is it a laundry room? Is it a wet room? We're getting those barriers away. Yeah. So really, a lot of our questions and safety devices are based around code and how they morph and the terminology behind it.
That's exactly right. Yeah, and some of the reasons why, like GFCIs,
right?
We measure from sinks, right? And we measure to what? The receptacle.
Right.
Yeah. But the receptacle's not the hazard. Okay, it's not like, oh my gosh, it's a receptacle. I can't touch it. I'm going to get electrocuted. No, it's what's plugged into the receptacle. And panel 2 right now is going through that realization, because it's not about where the proximity is of the receptacle to the water or to the sink. It's about the appliance to the sink, you know. And I get it, it's funny how you go, wait a second. But the reason we measure receptacles is because they're there during rough-in, during the construction. Right. And it's easy for inspectors and installers and everybody to know, okay, this has to be GFCI protected, this doesn't.
And to the point is, if you look, there's GFCIs. Now we have AFGFs in 10 times more places than we ever did in the past.
Yes.
And I haven't heard your story on AFCIs and the mystery. I missed your talk on
the mystery.
The mystery of
AFCI tomorrow.
Is
yes,
that tomorrow?
that is tomorrow.
Okay, so
yes, tomorrow afternoon.
I have to catch that.
And I have to say, so Nihat and I go live every morning, and we talk about our favorite presentation from the day before. So tomorrow morning, we're going to talk to everybody, and we're going to go live, talk about what happened today and what each of our favorite presentations were. Tomorrow, we both know what our favorite presentation is going to be. It's the mystery about AFCIs.
So I can't get anything out of them.
If you have any exhibitors that would like or need to draw a name for their own drawings, please bring me that information. Thanks.
Tell me about the mystery.
Oh my gosh. So what we do in our paper as a teaser for well, they're not going to see it. Okay. So what we try to do is talk about the reasons we have AFCIs. Yeah. We talk about the technology on how we detect arcs, how the standard helps us detect an arc and discriminate between the interference, right? And how the technology works. Then we talk about the migration through the National Electrical Code and the Canadian Electrical Code. Okay. And then we go over, now we have two parts, part 1 and part 2. Part 1 goes through history around how we got to where we're at, about the EIA, the organization that was saying that circuit breakers aren't doing their job, and we have all these electrical fires, and there was a gentleman walking around the country who was cutting wire and saying, look, the breaker's not functioning, and really the breaker industry turned lemons into lemonade, right? So they had someone, and they had an entire industry saying your breaker's not doing what it's supposed to do. And then we come over and say, okay, well, wait a second. I could have taken the defensive, the industry could have taken a defensive stance, but then they said, no, we're going to develop a technology that will detect that. Yeah, so we tell that story in that paper, and we provide that background, provide the statistics and the reasoning behind it, how the technology works, and then troubleshooting, and we have success stories.
And this will be on a podcast.
Well, it's going to be,
It'll be live in the room?
It'll be live in the room. So we have part 1 and part 2. Part 1 is the history. It's a poster board. Okay. Where we'll be out in the hallway, and myself and Nihat El Sharif will stand in front of the poster board, talk about it. Part 2 is more the technical. So we elected to do part 2 as the presentation, which is going to come first. And then part 1 is the history, which will be a poster board. So we'll be up on stage around in the afternoon, second to last, I believe. Okay. And then immediately after that, we will be at our poster board. And quite frankly, I know it's going to be hard to fight off all of the people who are going to want to be talking to us at the same time.
I'm sure you'll be overwhelmed. Yeah.
Oh, it'll be overwhelming. Yeah. So So
a couple things
yeah.
to point out. We are progressing in Wi-Fi devices, okay?
Oh.
For residential applications.
Yeah.
And Z-Wave, okay? So 2 ways to make things go on and off from all sorts of means and methods to automate a home or an apartment. Right?
That is absolutely awesome. So, and that's the wireless technologies to turn lights on. And we recognize it in panel 2, 210.70, I think. 210.70, we recognized that you can have some other control device that is wireless that can communicate and turn things on and off, like a light, you know, and that's the technology you're talking about.
You know, Z-Wave kind of started it with a kind of a robust mesh grid network.
Right.
Wi-Fi's moved in, become pretty substantial. You know, one has a little more robust and a little deeper that maybe an alarm integrator might want to put in.
Right.
Another would be a little more homeowner friendly.
Right.
But we're getting a lot of traction in that.
Excellent.
The controlled receptacles that we launched are starting to take hold for, you know, with the lead and the Title 24.
Yeah, Title 24 in California, and you have 90.1 ASHRAE standards 90.1, which was energy efficiency. You have to control so many percentage of your receptacles.
I would think probably one of the biggest things I'm excited about in the commercial arena is we're redesigning our modular devices for prefab.
Oh, yes.
Right.
Yes.
Big deal. Big deal.
Absolutely, that's a big deal.
Yeah, that's coming out in the fourth quarter of this year.
Really?
Yeah.
Prefabrication.
Yeah, we call it Easy Link will be the name of it. Easy Link.
Easy Link. Excellent.
Yeah, we're excited to have it.
Oh, I bet you are. Yeah. That's, and you know what? It gives, it just, I love when we can make things easier for electrical contractors and provide value. That's just
exactly. That's what it's about.
Labor savings is the name.
They're not necessarily less expensive, but they add the value.
That's exactly right. Absolutely. I love it. Yeah. This is good stuff. Who'd have thunk that a simple device like a receptacle can be so crazy?
Exactly.
Right.
Yeah.
Something like a 130-year-old design, right?
Exactly. Exactly. Well, that's phenomenal. So the age-old question: ground pin up or ground pin down?
Ground pin up.
Ground pin up guy. Okay.
Thank you very much for attending.
We're up. Excellent. That's good to know. Beautiful. Well, Chuck.
Very nice to meet you.
Nice to meet you. Thank you.
Tom, good to see you.
Good to see you. Thank you for educating.
Yeah.
You know what you do. Beautiful. Who would have thought? Yeah, go ahead. Do it. Receptacles are absolutely unbelievable. Unbelievable. The receptacle, the simple receptacle, color coordinated, cord and plug. You can see the color even though it's plugged in and you know the voltage levels. That's absolutely insane. I love it. I love it. Okay. Well, I think, agreed. I've been preaching surge protection for years. Lucas, thanks for joining in, buddy, and speaking your mind. I really appreciate you following and watching tonight. So hopefully everybody got something out of our time together in the booth, because I had booth duty. All right. So are we pretty much done? They're calling names. I really, everybody's telling me to shut it down. So thank you for watching, and you can remember this is up there on YouTube. You can watch it later. You can rewind. You can go back and say, did Tom really say that? Yes, I did. So I appreciate you hanging in there if you're still there. So take care, stay safe, and please remember, stay healthy, and I will see you soon on YouTube. Hit thumbs up, and don't forget to subscribe. All right, everybody. We will find me end. All right, take care, stay safe. We'll see you.